Since the beginning of time, humanity has looked upward, searching the sky for meaning. Long before telescopes, satellites, and probes, there were eyes, millions of them, staring into the vast night, tracing patterns among the stars and wondering if something, or someone, might be watching back. The question was never simply about distance or discovery. It was about belonging. Were we alone, or part of a much grander story written across the cosmos? The earliest civilizations seemed to feel that connection deeply. The Sumerians, under the heat of the Mesopotamian sun, recorded tales of gods descending from the heavens, their knowledge and fire shaping early humanity. The Egyptians built pyramids aligned with the stars, believing that their pharaohs would ascend beyond the sky to join divine beings. The Greeks spoke of worlds beyond worlds, of gods that ruled the constellations, and of mortal men who dared to touch the heavens. Every ancient culture, in its own way, wove the stars into its story, threads of light connecting myth, hope, and the unknown in the cool deserts of Central America. The Mayans built their temples to track the movement of planets. They believed the sky was alive, pulsing with order and purpose. To them, Jupiter, Venus, and Mars were not distant spheres but entities with intent, their dances marking time, fate, and prophecy. Meanwhile, far away in China, astronomers recorded celestial events with breathtaking precision: eclipses, comets, and new stars that appeared briefly before fading into memory. They watched the heavens like a mirror reflecting the rhythm of Earth, believing harmony existed between the movements above and the destinies below. Across continents, people felt a pull toward the infinite, sensing that the night sky held secrets too deep for words. Perhaps that's what makes these ancient stories so hauntingly beautiful. They remind us that wonder itself is ancient. It is older than science, older than civilization. It is the spark that pushed us to build fires, to gather and gaze upward, to find patterns and meaning in the stars. When the first humans sat by their campfires, surrounded by the darkness of an untamed world, they must have felt both small and infinite. Above them stretched a sky so vast, so filled with mystery, that it could not be ignored. The stars whispered possibilities, and our ancestors listened. Over the centuries, as empires rose and fell, that same question endured. In the temples of India, sages meditated on the infinite cycles of creation, picturing endless worlds, each filled with beings on their own paths of discovery. In Greece, philosophers like Epicurus and Democritus dared to suggest that the stars might be suns like our own, each surrounded by unseen worlds. To say such things then was bold. It meant accepting that Earth might not be the center of everything, that we might be one world among countless others drifting through a boundless sea. Yet even without proof, imagination filled the gaps where knowledge had not yet reached. The night sky became a stage for our hopes and fears. It was home to gods, monsters, spirits, and dreams. Every culture used it as a canvas to project their stories, their questions, and their longing. Why were we here? Were we special? Were we watched, guided, or forgotten? These questions echoed quietly through the ages, carried in the songs of travelers, the prayers of priests, and the sketches of early astronomers mapping the heavens in the Renaissance. As glass lenses began to sharpen our view of the stars, humanity's ancient wonder took on a new shape. The myths did not fade, they evolved. Seeing the moons of Jupiter for the first time, Galileo must have felt the same mix of fear and excitement that a Babylonian stargazer felt thousands of years before. The sky was changing from divine mystery to scientific reality, yet its emotional power remained untouched. Looking up still stirred the same longing, the same quiet awe, and so, even now, when we send probes to the outer edges of the solar system or peer through powerful telescopes that capture light from galaxies billions of years away, we are continuing a conversation that began in the hearts of our ancestors. We might use new tools, new names, and new theories, but the essence is unchanged. We are still the same curious beings, tracing light in the dark, wondering who, or what, might be out there. This fascination, this unbroken thread of curiosity, binds us across generations. It is the one constant in humanity's story. No matter how much we learn, the stars continue to whisper questions we cannot yet answer. And perhaps that is what keeps us searching, not the need to conquer the unknown, but the quiet hope that somewhere, among those distant lights, lies another story waiting to meet ours. What is life? It sounds like a simple question, but it has puzzled scientists, philosophers, and dreamers for centuries. We all think we know it when we see it: a flower blooming, a cat stretching, a heartbeat pulsing under warm skin. Yet, when we try to define life precisely, the lines blur. Is it movement? Growth? The ability to reproduce? To sense and react? Each attempt to describe life seems to open more questions than it answers. In the quiet halls of biology, scientists have tried for decades to capture the essence of life in words and formulas. The most common definition describes it as a self-sustaining chemical system capable of evolution. In simpler terms, life is something that can use energy, reproduce, and change over time. It takes in matter and energy from its surroundings, uses it to build and maintain itself, and passes on its structure through reproduction. On Earth, life does this through cells, the tiny, intricate units that make up everything from the simplest bacterium to the most complex human brain. But even this definition isn't perfect. There are strange, gray areas that refuse to fit neatly into our categories. Take viruses, for instance. They can reproduce and evolve, but only by hijacking the machinery of a living cell. On their own, they are inert, more like tiny packages of genetic code than living things. Are they alive? Some say yes, in a minimal sense. Others say no, that they are simply clever fragments of chemistry pretending to be alive when given the right host. The debate continues, showing just how slippery the idea of life truly is. When scientists study life, they look for shared traits: metabolism, growth, reproduction, response to stimuli, and adaptation. These characteristics describe what life does, rather than what it is. On Earth, all known life is based on carbon chemistry. Carbon, with its flexible bonding properties, forms the backbone of complex molecules like DNA, proteins, and carbohydrates. Water acts as the medium, dissolving nutrients and carrying energy through countless reactions that sustain existence. Life, as we know it, is a delicate dance of molecules, guided by laws of physics, but full of astonishing complexity. Still, our experience of life is narrow. Everything we know comes from one planet, one set of conditions, one example. The deeper we look into the universe, the clearer it becomes that our version of life might just be one chapter in a much larger book. Scientists now wonder whether life could exist in ways we have yet to imagine, perhaps made of silicon instead of carbon, swimming in methane instead of water, breathing chemicals unfamiliar to us. Could something very different still meet the essence of what we call alive? Astrobiologists explore this question with both humility and curiosity. On Mars, they search for traces of ancient microbes, perhaps long extinct but once thriving in the planet's watery past. On the icy moons of Jupiter and Saturn, Europa and Enceladus, they imagine oceans beneath the frozen crust, warmed by tidal forces, rich in energy and chemistry. Could life swim there, unseen, under kilometers of ice? It's possible. In those dark alien seas, life might not look like fish or plants or anything familiar. It could be something small, strange, and silent, perhaps microbes that feed on minerals and heat instead of sunlight. Even more mind-bending is the idea that life could exist in forms that defy our senses altogether. Some scientists speculate about plasma-based life in stars or clouds of charged particles drifting in the atmospheres of gas giants. Others imagine digital or quantum forms of life, where consciousness could emerge from patterns of information rather than molecules. Each idea stretches our understanding, reminding us how limited our imagination can be when shaped by one world's experience. To define life only by what we know would be to close our eyes to what might be. When we say life, we often picture Earth, trees, birds, whales, humans, but the universe may not share our template. Life elsewhere could be built on principles we've never seen. It might not breathe, eat, or grow as we do. It might not even be bound by the same chemistry. And yet, it could still feel the flow of time, experience change, and strive to persist. Some scientists have suggested that perhaps life is not a single category but a spectrum, a range of self-organizing systems that reach varying degrees of complexity and independence. On one end, there might be simple replicating molecules, the first sparks of order in chaos. On the other, conscious beings capable of self-awareness and curiosity. Between them lies everything we know and much we do not. In this view, life is not a checklist, but a continuum, a gradual unfolding of patterns from simplicity to richness. When you step back and think about it, this uncertainty is beautiful. It reminds us that life is not just a scientific concept, it's a wonder. The fact that we can even ask these questions means we are part of the mystery we're trying to solve. The molecules in our bodies, forged in ancient stars, have come together in just the right way to think, to feel, and to wonder about themselves. We are living evidence that the universe can become curious about its own existence. Defining life, then, might be less about drawing boundaries and more about recognizing connections. Every living thing on Earth, from the smallest microbe to the tallest redwood, shares a common origin. All are branches of the same tree, reaching outward through time. And perhaps, beyond our tiny corner of space, other trees have grown too, different, unfamiliar, but rooted in the same cosmic soil. So, what is life? Maybe it is not just chemistry or biology. Maybe it is the universe's way of expressing itself in countless forms, matter becoming aware, exploring, and reaching toward understanding. Life might be the story of the cosmos learning to see itself, and in that quiet realization lies something profound. To search for life beyond Earth is not only to look for others, it is to rediscover ourselves. It is to see our fragile existence not as an exception, but as part of a vast, unfolding tapestry. Somewhere, perhaps very far away, other forms of life may be wondering the same thing we are. What is life? What does it mean to be here, now, under this sky of endless stars? When we think of life, we picture what we can see: trees rising from the soil, birds gliding through air, people breathing, moving, speaking. But what if life is not always visible? What if existence can take forms that slip quietly beyond our senses, hidden in layers of reality we've never learned to notice? The universe, vast and ancient, might be filled with forms of being that our eyes, our tools, and even our imaginations cannot yet reach. It's a humbling thought, one that stretches the idea of life far beyond the borders of biology and into the deep unknown. Even here on Earth, life hides in ways that once seemed impossible. We've found bacteria living miles underground, in rocks older than our species. We've discovered microbes thriving in boiling acid, beneath frozen lakes, and around vents that gush scalding chemicals into the deep sea. These creatures live without sunlight, without oxygen, sometimes even without what we'd call food. They rewrite the rules of survival, proving that life can adapt to nearly any environment. If such resilience exists here, on one small planet, how much more could the universe hold? Scientists call these hidden forms of life extremophiles, but maybe that name reflects our own limits more than theirs. To them, their worlds are not extreme, they're simply home. It makes you wonder, could entire ecosystems exist in conditions we've never considered habitable? In the dense clouds of Venus, where temperatures soar and acid rains fall, or beneath the icy crusts of moons circling distant planets, life could quietly flourish in ways we'd barely recognize. Perhaps it moves slowly, exchanging energy through chemistry unknown to us, growing, sensing, and living out its purpose far from our gaze. And maybe the unseen isn't only far away. Perhaps it's closer than we imagine. The air around us swarms with countless microorganisms we never notice. Our oceans hold species that have never been named, their existence known only through faint traces of DNA drifting in the water. Even our own bodies are hosts to invisible communities, trillions of microscopic companions shaping our health, emotions, and thoughts. We coexist with entire worlds we cannot see. The familiar, when looked at closely, becomes mysterious again. But what if the unseen goes deeper still, not just hidden by size or distance, but by perception itself? What if there are layers of reality tuned to frequencies our senses cannot detect? Some physicists have wondered whether the universe could host dimensions beyond the three we move through. If so, could something alive exist there, beings made of patterns or energies that weave through space in ways invisible to us. We might share the same cosmic room with life forms that neither see us nor are seen by us, each unaware of the other's existence, separated by the simple limits of perception. This idea isn't entirely new. Ancient philosophies spoke of unseen spirits in nature, consciousness flowing through wind, water, and stone. Modern science has stripped much of that language away, but perhaps not the mystery beneath it. Quantum physics reveals that matter itself is not solid but a dance of probabilities, flickering between presence and absence. In that strange dance, could there be configurations that support awareness? Could life arise not from matter as we know it, but from the very patterns of reality itself? It's an unsettling and beautiful thought that existence may be more layered, more alive, than we can ever fully grasp. Perhaps what we call inanimate is only sleeping. Perhaps awareness hums softly in every atom, every wave of light, waiting for the right conditions to awaken. In this view, the universe isn't a cold emptiness punctuated by rare sparks of life. It's a living field, constantly creating, evolving, and experimenting. Life would not be the exception but the rule, flowing through everything, sometimes visible, sometimes hidden that we stand. Then, in a universe that may be teeming with company, though we've barely learned how to listen. Our instruments are improving, telescopes peering at exoplanets, probes touching alien worlds. But maybe the next frontier isn't out there. Maybe it's in learning to sense differently, to notice the quiet signals of existence we've overlooked. Just as early humans once mistook the stars for pinholes in a dark sky, we may be mistaking the universe's deeper patterns for emptiness simply because we don't yet understand what we're seeing. So, could life be everywhere, even unseen? The honest answer is that we don't know, but the possibility itself changes everything. It softens the edges of our certainty. It reminds us that mystery still lives among the familiar, that what we call nothing might be something beyond imagination. The thought doesn't demand belief. It invites wonder. Next time you look at the night sky, consider this. Every point of light could be a world. Every world could hold life. And every life could exist in ways we have no language to describe. Even here, in the silence between stars, the universe may be whispering stories we're only beginning to hear. And perhaps, if we stay quiet long enough, we'll learn to listen, not just with our instruments, but with our curiosity, our openness, and our awe. Because in a universe this vast, the unseen might not be empty at all. It might be alive. Long before science offered telescopes or equations, the sky was already filled with stories. To ancient eyes, the heavens were alive, inhabited by beings that watched, guided, and sometimes interfered in human affairs. Every culture looked upward and saw more than just stars. They saw movement, purpose, and presence. These myths were not primitive mistakes. They were early expressions of a deep human longing. The feeling that we are not alone in the vastness above us. In ancient Mesopotamia, the cradle of civilization, stories spoke of powerful visitors who descended from the heavens. The Sumerians called them the Anunnaki, divine figures who shaped the world and taught humankind knowledge. Their myths blurred the line between gods and beings from the stars. Carvings showed winged figures holding mysterious tools, their faces calm and watchful. Whether gods, symbols, or something in between, they embodied humanity's first attempts to understand the unknown lights that moved across the sky. Far to the west, in Egypt, the heavens were seen as a divine realm of transformation. The pharaohs believed that when they died, they would ascend to the stars to live among the gods. The pyramids themselves were designed as stairways to the sky, their alignment with constellations reflecting a belief that the stars were both a destination and a beginning. The god Ra traveled across the heavens each day in his solar boat, bringing light to the world, then journeyed through the underworld by night, a cycle that mirrored both cosmic order and the rhythm of life itself. In every sunrise, they saw the spark of divine presence, and in every star, a gateway to eternity. The Greeks turned the sky into a grand tapestry of stories. The constellations were not random points of light, but heroes, monsters, and gods frozen in celestial memory. Zeus ruled the heavens, hurling lightning from his throne among the clouds. Hermes flew between worlds, carrying messages from Olympus to Earth. When strange lights appeared, comets, eclipses, or meteors, they were seen as omens, signs that the gods were stirring. The sky was not distant to them. It was a living stage where cosmic forces revealed themselves in brilliant, fleeting moments. Across the ocean, the peoples of the Americas looked upward with their own reverence. The Maya and Aztecs watched the skies with precision and awe, building calendars so exact that even modern astronomers admire them. They believed the gods descended from the stars to create humankind, and that the heavens held the balance of life and death. The Inca traced their origins to the sun itself, calling their emperor the child of Inti, the sun god. To them, the sky was not just a realm of divine beings, but the very source of human existence. In Australia, the Aboriginal peoples told stories of the Dreamtime, when ancestral beings shaped the land and sky. They saw the Milky Way as a river of creation, its patterns mirrored in the landscapes below. The stars were guides, storytellers, and keepers of memory. For them, the cosmos was not distant. It was continuous with the Earth, part of the same living system. To look up was to remember where you came from. And in the ancient Vedic texts of India, the sky was filled with celestial beings called devas, radiant presences who govern natural forces and cosmic laws. Some stories describe them as travelers between realms, beings of light and energy, connected to both the physical and the spiritual. In later centuries, as philosophers pondered the nature of existence, some began to imagine other worlds entirely. Countless universes, each filled with its own forms of life, consciousness, and destiny. Though the details differed, a single thread connected these stories across continents and centuries: the belief that the universe was inhabited, that the sky was not empty but full of intention. For early humans, this idea offered comfort. The vast unknown became personal, full of meaning and companionship. The heavens were not a silent void. They were alive, watching, and in some mysterious way, connected to us. Even today, echoes of these ancient myths remain. Modern tales of extraterrestrials and cosmic visitors carry traces of the same wonder that once inspired temple builders and storytellers. The difference is in language, not in spirit. Where the ancients spoke of gods descending from the heavens, we now imagine travelers from distant stars. Where they offered myths, we offer hypotheses. But the desire behind both is the same: the wish to find reflection and connection beyond ourselves. That it's tempting to see those old stories as superstition, but they were humanity's first steps toward cosmic thought. Each myth, in its own way, was a form of exploration. Without telescopes, ancient people still mapped the heavens, searching for meaning in its patterns. They built observatories of stone and memory, trying to decode the messages written in light. Their stories became the earliest framework for what we now call the search for life beyond Earth. When we listen to those ancient voices, we can still feel their awe. Imagine a night thousands of years ago, somewhere on a quiet plain. A group of people gathers around a fire, staring at a sky untouched by city lights. The stars shimmer like jewels scattered across infinity. Someone points to a bright one, moving slowly, and whispers that it is a traveler, a god, a messenger, a being watching over them. The fire crackles, the stars turn, and in that timeless moment, humanity's curiosity awakens. That feeling has never left us. Though our tools have changed, our questions remain the same. What lives among the stars? Who, if anyone, looks back at us? The myths of beings from the sky were not answers. They were invitations to wonder. They remind us that imagination was our first telescope, and that the story of our search began not with data, but there was a time, not long ago in the grand story of the cosmos, when the stars were forever out of reach. They burned above us, perfect and distant, their secrets locked behind the limits of human sight. For thousands of years, we gazed upward and guessed, tracing patterns, telling stories, worshiping what we could not touch. But then, something changed. One small piece of glass, carefully shaped and placed within a wooden tube, gave humanity its first real glimpse into the infinite. That simple tool, the telescope, transformed our relationship with the sky forever. It began quietly, almost humbly, in the early 1600s. Across Europe, Curiosity stirred in minds hungry for understanding. The Renaissance had already reignited human wonder. Artists painted perspective into their canvases, scientists questioned old beliefs, and philosophers sought order in the chaos of nature. Then came a discovery that turned eyes outward once more. In the Netherlands, lens makers experimenting with spyglasses found they could make distant objects appear closer. Their invention was meant for navigation and warfare, but when word of it spread, one man saw a deeper possibility. In 1609, an Italian mathematician named Galileo Galilei turned one of these instruments toward the heavens. It was a modest device, his first telescope magnified only about 8 times, but through it, the universe opened like a curtain being drawn back. What he saw shattered centuries of certainty. The moon, once thought to be a perfect celestial sphere, revealed itself to be scarred and rugged, covered with mountains and craters. Jupiter, that bright wandering star, was surrounded by 4 tiny points of light that moved in perfect rhythm. Moons, worlds orbiting another world. It was a revelation that shook the foundations of human thought. Galileo's discoveries were more than observations. They were awakenings. For the first time, humanity had proof that Earth was not unique, not the fixed center of creation. The heavens were not a crystal dome, but a vast expanse filled with motion, structure, and life in motion. Galileo sketched what he saw by candlelight, his trembling hands tracing the moons of Jupiter, the phases of Venus, the dark spots crawling across the face of the sun. Each drawing was a quiet revolution. He was seeing with his own eyes what no human had ever seen before. When his findings reached the world, the reaction was mixed: admiration, disbelief, fear. Some hailed him as a genius, others called him dangerous. His telescope was more than a tool. It was a challenge to the old order. If Earth was not the center, if other worlds circled distant suns, then what else might be true? For Galileo, the telescope was a key, and he had just begun to turn it. Meanwhile, in other corners of Europe, the hunger to explore the heavens was spreading. Johannes Kepler, working in the cold light of mathematics, used precise data to describe how planets moved in ellipses rather than perfect circles. His laws of motion revealed an elegance in the chaos, a hidden harmony in which everything obeyed the same simple truths. And then came Isaac Newton, who showed that the same force pulling an apple to the ground kept the moon in its orbit. The heavens and the earth were not separate realms. They were bound by the same law. The telescope had not only revealed new worlds, it had united them under one cosmic order. Through the 17th and 18th centuries, telescopes grew larger, clearer, more powerful. William Herschel, a musician turned astronomer, built massive instruments in his backyard, their mirrors shining like captured starlight. One night in 1781, as he swept the skies from his garden in England, he spotted a faint, slow-moving dot that was not in any chart. It was a new planet, Uranus, the first discovered since ancient times. That single observation expanded the known boundaries of our solar system, proving the universe held more than even the boldest minds had imagined. Herschel's telescope also revealed star clusters, nebulae, and the faint glow of galaxies far beyond our own. He suspected that the Milky Way was just one island in a vast cosmic ocean, filled with countless others. The thought was staggering, almost unthinkable. Humanity's little blue planet, circling a modest star, was part of something immeasurable. The more we looked, the smaller we seemed. And yet, the more magnificent the story became. By the 19th century, telescopes had become monuments to curiosity. On lonely hills and quiet mountains, great domes rose, their instruments aimed toward the endless dark. Astronomers spent cold nights at their eyepieces, sketching what they saw through frost and fatigue. Each observation added another piece to the puzzle of existence. Spectroscopes, attached to telescopes, revealed that the stars were made of the same elements found on Earth: hydrogen, helium, oxygen. The universe, it turned out, was not foreign. It was KIN.AS. We learned more. The sky began to change again, not in what it was, but in how we saw it. No longer the home of gods or omens, it became a living system of stars being born, dying, and scattering their elements into space. Those elements, forged in stellar fires, would one day become planets, oceans, and living beings. The telescope, that simple lens of glass, had revealed that we are made of the same matter as the stars themselves. We are stardust, as the poet would later say, not metaphorically, but literally. Yet for all its discoveries, the telescope also deepened the mystery. Every answer uncovered more questions. What were the faint cloudy shapes beyond the Milky Way? Were they merely gas or other galaxies, perhaps even other universes? Could life exist on those distant worlds? Could someone, somewhere, be looking back at us through their own telescope, wondering the same thing? As the 20th century dawned, technology leapt forward again. Giant observatories rose in California, Chile, and Hawaii, peering farther into space and time than ever before. Then came the space age, rockets lifting telescopes beyond the distorting veil of Earth's atmosphere. When the Hubble Space Telescope launched in 1990, it was as if our vision finally cleared. From its quiet orbit above the world, Hubble captured images of galaxies stretching billions of light-years away. Each image was a window into the past, a glimpse of creation itself unfolding. In those photographs, the universe looked alive, filled with color, motion, and possibility. Nebulae glowed like cosmic nurseries, galaxies spiraled in elegant symmetry, and clusters of stars shimmered like city lights scattered across the dark. Humanity, after centuries of wondering, was finally seeing its cosmic home in detail. And yet, even amid the beauty, one question lingered. If life exists elsewhere, why haven't we seen it? That question continues to echo today. Modern telescopes, some on Earth, others orbiting far beyond, search not only for stars, but for signs of life. They analyze starlight for the chemical fingerprints of oxygen, methane, and water vapor, clues that a planet might be alive. Each discovery brings both excitement and humility. We are explorers standing on the shore of an infinite sea, dipping our first instruments into its depths. When we look through a telescope, we are not just observing the universe, we are participating in it. The light that enters our eyes began its journey long before there were humans to see it. Some of that light left its star before Earth was even born. In that sense, every telescope is a time machine, letting us glimpse the ancient past and wonder about the endless future. The dawn of cosmic curiosity began with one man lifting a small tube to the sky, but what followed was a transformation of spirit. The telescope taught us that the universe is not static or perfect. It is alive with change, motion, and creation. It showed us that we are not separate from the cosmos, but a continuation of it. And perhaps most beautifully, it reminded us that discovery is not about ending mystery, but deepening it. Each new lens we build, each new world we glimpse, adds another verse to humanity's song of wonder. We began by telling stories about gods and stars. Now, we write our own story among them. The telescope was our first bridge from myth to science, from imagination to understanding, and through it, the universe became both larger and more intimate. We looked outward and, in doing so, began to truly see. There was a time when the question of life beyond Earth was not one of science, but of poetry. People gazed at the night sky and wondered who might be looking back. But as humanity grew more curious, that wonder began to take on the language of evidence. Out of philosophy and astronomy, a new branch of curiosity slowly took shape, one that sought not only to imagine, but to know. This was the birth of astrobiology, the science of life among the stars. Its roots stretch back to the middle of the 20th century, when the world itself was changing faster than ever. Rockets were leaving the ground, and for the first time, we could imagine reaching other worlds, not just dreaming about them. It was during this moment of technological awakening that scientists began to seriously ask, if life exists elsewhere, what would it look like? What would it need to survive? And how could we even begin to search for it? Astrobiology did not start with a single discovery or a single person. It was more like a quiet gathering of minds, astronomers, biologists, chemists, and philosophers, each realizing that their questions had begun to overlap. The chemistry of carbon, the physics of planetary atmospheres, the biology of microorganisms, all pointed toward the same mystery, life. It wasn't enough to study Earth in isolation anymore. To understand life, scientists had to look outward, to the stars, to other planets, to whatever lay beyond. One of the earliest sparks came from an unlikely place, the study of extreme life on Earth. Deep in the oceans, At volcanic vents where sunlight never reached, strange organisms thrived in boiling darkness. In the frozen deserts of Antarctica, bacteria clung to ice crystals, surviving where almost nothing else could. Life, it seemed, did not obey the rules we once thought it did. It was resilient, inventive, endlessly adaptable. If it could flourish in these alien corners of our own planet, why couldn't it do so elsewhere? Mars, Europa, Enceladus. These worlds began to look a little less empty to eye in the 1950s. A bold experiment gave the idea new strength. Stanley Miller and Harold Urey, two scientists at the University of Chicago, decided to recreate the conditions of early Earth inside a glass flask. They mixed water, methane, ammonia, and hydrogen, simple gases thought to exist on the young planet, and sparked them with electricity, simulating lightning. Within days, the clear liquid had turned pink. When they analyzed it, they found amino acids, the building blocks of life. It was the first time anyone had shown that organic molecules could arise from raw chemistry alone. Life, it seemed, was not a miracle confined to Earth. It might be a natural outcome of the universe itself. This experiment sent ripples through science and imagination alike. If life's ingredients could form so easily, perhaps the cosmos was full of them. Every planet, every moon, every cloud of gas could be a potential cradle of creation. Suddenly, the search for life was not just philosophical. It was experimental, measurable, and deeply exciting. NASA soon joined the conversation. The agency began to fund studies of biology in space, from the effects of microgravity on living organisms to the chemistry of Martian soil. In 1960, Frank Drake, an astronomer with a quiet sense of purpose, turned a radio telescope toward the stars in an experiment he called Project Ozma. He was listening for signals, deliberate, structured, intelligent sounds from another civilization. He didn't find any that day, but his attempt marked a new chapter in human curiosity. The question was no longer if we should search, but how the field began to mature. In 1965, NASA established the exobiology program, a forerunner to modern astrobiology, devoted entirely to studying life beyond Earth. Around the same time, Carl Sagan, one of the most eloquent voices in science, became one of its most passionate advocates. Sagan reminded the world that searching for life elsewhere was not a distraction, but a way to better understand ourselves. He famously said that we are a way for the cosmos to know itself. His words captured both the poetry and the purpose of astrobiology, that by studying life in the universe, we are studying the universe through the lens of life. As the decades passed, missions to Mars, Jupiter, and Saturn deepened this pursuit. The Viking landers of the 1970s carried experiments to test Martian soil for biological activity. They didn't find conclusive evidence of life, but they raised profound questions. Later, spacecraft like Galileo and Cassini revealed oceans hidden beneath icy crusts on moons such as Europa and Enceladus. Water, once thought rare, turned out to be abundant across the solar system. It was becoming clear that the ingredients for life, water, energy, and organic molecules, might not be special to Earth at all. At the same time, astronomers began discovering planets around other stars, exoplanets. The first confirmed one was found in 1992, orbiting a pulsar. By the late 1990s, more and more planets were being detected, some roughly Earth-sized, some in the so-called habitable zone, where liquid water could exist. Today, there are thousands known, and the list grows each year. Each one is a potential home, a potential story waiting to unfold. Astrobiology grew with each discovery. It became not just a scientific field, but a bridge between disciplines, between questions, between hope and evidence. It taught us that life is not defined by where it exists, but by its ability to adapt, to persist, to transform. It made us rethink what it means to be alive, and to ask whether the spark of life might be a common thread woven through the vastness of space. The tone of the field remained gentle yet ambitious, a balance between humility and curiosity. Scientists knew that answers might take centuries, that proof might remain just out of reach. But the pursuit itself became part of the human story, a reflection of our desire to connect. To search for life elsewhere is to reach beyond loneliness, to wonder if we are part of something larger, something ongoing, something universal. And perhaps that is the quiet truth of astrobiology, that it's not just about finding microbes on Mars or civilizations among the stars. It's about understanding that life, wherever it exists, is an expression of the same cosmic chemistry that made us. It's about recognizing that we, too, are products of stardust and time, that we belong to the same unfolding pattern as everything else in the universe. So when we look up at the night sky and ask, are we alone? We are really asking a deeper question, one about connection, origin, and meaning. The birth of astrobiology was humanity's first scientific attempt to answer that question. And though the answer remains unknown, the search itself has already changed us. It has made our small world feel both precious and shared, a tiny, living thread in the fabric of something infinite. Long before we looked to the stars for life, the Earth itself held secrets we had not yet imagined. Hidden in boiling vents at the bottom of the ocean, frozen within glaciers, buried deep in rocks and salt crystals millions of years old, life was not just surviving, it was thriving. These tiny, stubborn forms of existence came to be known as extremophiles, organisms that lived where life was never expected to endure. Their discovery changed everything we thought we knew about what it means to be alive, and it whispered a quiet truth. If life can exist here, it can exist almost anywhere. The story of extremophiles began in places most of us would never dare to go. Deep beneath the sea, along the mid-Atlantic ridge, scientists exploring hydrothermal vents discovered towering black chimneys spewing water hot enough to melt metal. In this lightless abyss, they expected nothing to live. Yet there, clustered around the vents, were entire ecosystems, giant tube worms with crimson plumes, ghostly crabs, and microbial mats shimmering like underwater carpets. These microbes were not powered by sunlight like all known life above. Instead, they drew energy from the chemicals in the vents: sulfur, iron, methane. They lived by chemosynthesis, transforming the chemistry of the earth into nourishment. Life, it seemed, had found a way even in eternal darkness. The amazement only deepened when scientists began to look elsewhere. In the frozen deserts of Antarctica, they found colonies of microorganisms locked in ancient ice, asleep for centuries, yet capable of awakening when given water. In the scorching springs of Yellowstone, bacteria flourished in water hot enough to boil an egg. In the salt flats of Chile's Atacama Desert, microbes survived where rainfall was almost non-existent. Even in nuclear reactors, in clouds, and miles beneath the surface in rocks where sunlight had never reached, life persisted. The message was simple but profound. Earth was not a fragile oasis. It was a world of survivors. Some extremophiles endure heat that would destroy most life in seconds. These are thermophiles, capable of living in temperatures above 100 degrees Celsius. Others, psychrophiles, thrive in sub-zero conditions, their cells producing special proteins that prevent ice from tearing them apart. Halophiles live in salt concentrations that would dehydrate nearly every other organism. Acidophiles survive in environments as corrosive as battery acid. There are even radiophiles, organisms like Deinococcus radiodurans, that can withstand levels of radiation thousands of times higher than what would kill a human. Each of these tiny forms of life represents a different kind of defiance, a reminder that nature's imagination exceeds our own. The discovery of extremophiles didn't just expand biology, it redefined our sense of possibility. For decades, scientists had assumed that life required mild, Earth-like conditions, liquid water, moderate temperatures, a stable environment. But extremophiles proved that life could adapt to extremes we once thought impossible. They forced us to rethink the boundaries of habitability. Suddenly, the icy moons of Jupiter and Saturn, Europa, Enceladus, Titan, no longer seemed lifeless. The idea that beneath their frozen crusts, in dark oceans warmed by the pull of gravity, microbes could be thriving felt entirely plausible. Even the scorching, acidic clouds of Venus and the dusty plains of Mars became suspect. Where there is energy, chemistry, and time, life might find a way. What makes extremophiles truly awe-inspiring is not only their endurance but their elegance. Their survival strategies are stories of adaptation at the edge of existence. Some produce unique enzymes that work at temperatures that would destroy ordinary proteins. enzymes now used in DNA research and industrial processes on Earth. Others can repair their DNA faster than it breaks, or go dormant for thousands of years, waiting for a moment when conditions become right again. They show us that life is not fragile but resourceful, not static but endlessly inventive. To scientists, each new discovery felt like a glimpse into alien biology right here on our own planet. Studying these organisms became a way to explore what life elsewhere might look like. When NASA plans missions to search for microbes beneath Mars's surface or within the oceans of Europa, they look first to Earth's extremophiles for guidance. The color of a bacterial mat in a Yellowstone pool, the chemistry of an acid-loving microbe, or the metabolism of a methane-eating organism. All of these hold clues to how life might survive beyond Earth. In a sense, extremophiles became our ambassadors of possibility, tiny messengers from the edges of what we once thought life could be. Yet beyond science, there's something deeply humbling about their existence. These creatures, invisible to the naked eye, have endured since long before humans walked the earth. They survive without comfort, without light, without any sign of luxury or beauty, and yet they flourish. They remind us that life is not measured by ease, but by persistence. They tell a story of quiet resilience that stretches across the ages and across worlds. When we think of life in the universe, we no longer picture only green valleys or blue oceans. We imagine frozen moons, boiling seas, toxic skies, and still, somewhere within them, something living, adapting, and enduring. Extremophiles taught us that life is not a rare spark that flickers briefly, but a flame that reshapes itself to survive. In every drop of acid, in every grain of salt, in every corner of fire and ice, they whisper the same truth. Life does not wait for perfect conditions. It creates them. And if it can do so here, in the harshest places of our own small world, then perhaps it is doing so elsewhere, unseen, quietly thriving in the impossible. Imagine for a moment that we are not alone, not across the galaxy, but here, on Earth. That somewhere in the soil, in the oceans, in the air we breathe, another form of life exists, quiet, invisible, and different. Not alien in the sense of distant worlds, but alien in the sense of chemistry. A shadow biosphere, scientists call it, a hidden layer of life built not from the same rules that shaped us, but from an alternate version of biology, one that has been here all along, unnoticed. The idea sounds like science fiction, but it was born from science itself, from curiosity about how narrow our definition of life might be. For centuries, we have looked at living things through the lens of what we know. All known life on Earth, from the smallest bacterium to the tallest tree, shares the same basic chemistry. It is all made from DNA or RNA, relies on carbon, uses water as a solvent, and depends on the same 20 or so amino acids. It's a comforting unity, a sign that all living things are, in some way, relatives. But what if that unity is only part of the story? What if another kind of life, built on different molecular foundations, evolved alongside us and continues to exist in niches we've never noticed or cannot detect? This possibility, the shadow biosphere, challenges one of science's quiet assumptions, that all life is detectable by the same tools. We design our microscopes, our culture dishes, and our DNA tests based on the biochemistry we already understand. Anything that doesn't fit those expectations would be invisible to us, not because it isn't there, but because we aren't looking for it in the right way. A shadow biosphere could exist right beneath our noses, its organisms thriving in places we think are sterile or lifeless simply because our instruments don't recognize their chemistry. The idea first began to take shape in the early 2000s, when a small group of scientists, including astrobiologists and microbiologists, began to notice something strange. There were environments on Earth, salty lakes, deep deserts, acidic pools, where not all of the organic material seemed to match known forms of life. Some of the carbon signatures were unusual, behaving differently under analysis. It was as if some of the biomass didn't belong to our known tree of life. These anomalies could have been errors, but they also opened a provocative question. Could we be surrounded by life that operates with a completely separate genetic system? To imagine what that might mean, we have to think beyond the biology we know. Our life depends on DNA, which uses 4 familiar bases: adenine, thymine, cytosine, and guanine, arranged in a delicate spiral. But chemically, there is no reason why other base pairs couldn't exist. Laboratory experiments have already shown that artificial organisms can be made with 6 or even 8 genetic letters instead of 4, creating entirely new codes for life. Some researchers believe nature itself could have tried such experiments billions of years ago. Perhaps, in Earth's ancient oceans, multiple forms of life arose, some leading to the DNA-based lineage we know, others taking different biochemical paths. Our version won the evolutionary race for dominance, but the others might never have vanished completely. They could have retreated into hidden corners, surviving in isolation, unnoticed, forming a quiet, parallel biosphere. The thought is unsettling, yet beautiful, that beneath the visible web of life lies another, woven from different threads. These hypothetical organisms might not use water at all. They might rely on ammonia, or methane, or even silicone-based chemistry. They might not breathe oxygen or carbon dioxide, but something else entirely. They might not even appear alive to us, perhaps forming films or patterns that we dismiss as mineral deposits or chemical residue. To us, they would look like dust, yet to themselves, they might be an entire world. Some scientists have tried to find hints of such life. In 2010, researchers studying the harsh, arsenic-rich waters of Mono Lake in California made headlines when they suggested they had found bacteria capable of substituting arsenic for phosphorus, one of the key elements of life as we know it. If true, it would have been evidence of a truly alien biochemistry existing on Earth. Later studies challenged that claim, suggesting the organisms still relied on ordinary phosphorus after all. But even if that specific example faded, the larger idea did not. It pushed scientists to keep looking, to search in ways that weren't limited by our familiar assumptions. The search for a shadow biosphere has become, in many ways, a philosophical quest as much as a scientific one. It forces us to confront the limits of perception. We look for what we already know how to see, and in doing so, we may overlook what is truly different. If a shadow biosphere exists, then our understanding of life's diversity is incomplete. We are seeing only one branch of a much larger, more complex forest. It would mean that the universe's ability to create life is even broader and more creative than we ever imagined. This possibility has profound implications for astrobiology. If multiple biochemistries can coexist on one planet, then other worlds, Mars, Europa, Titan, may also host more than one form of life. It could mean that the search for extraterrestrial organisms must remain open-ended, not limited to Earth-like signatures such as oxygen or carbon-based molecules. Life elsewhere might be stranger, subtler, built on patterns we have not yet learned to recognize. The first alien life we find might not come from the stars at all. It might come from our own planet, hidden all along. Beyond science, the shadow biosphere idea invites a deeper kind of reflection about awareness, humility, and our place in nature. We often assume we are observant, that our instruments and intellects give us mastery over our surroundings. But perhaps reality is far richer than our senses allow. The notion that an entire parallel world of organisms could share our planet unseen is both eerie and enlightening. It suggests that existence itself may be layered, visible and invisible, familiar and foreign, known and unknowable. It also reminds us that mystery still lives close to home. We do not need distant galaxies or alien civilizations to experience wonder. The soil beneath our feet might hold it. The dust on a windowsill, the shimmer of a mineral crust, the unseen depths of a lake, all might be hosts to life forms that defy every definition we have built. The universe, it seems, keeps its secrets close, whispering them only to those willing to look differently. In the end, whether or not a shadow biosphere is ever proven, its idea performs an important service. It keeps our curiosity alive. It reminds us that knowledge is not a closed circle, but an expanding horizon. It encourages scientists to question the very tools they use, to remain humble before the unknown. And it invites all of us to wonder if the boundaries we draw between living and non-living, between earthly and alien, are far blurrier than we imagine. Perhaps the shadow biosphere, if it exists, is not just a hidden form of life, but a reflection of a deeper truth, that existence itself is layered with meanings we haven't yet learned to read. Life may not be a single flame burning in the darkness, but a spectrum of light, some visible, some unseen, each illuminating a different corner of reality. And maybe, just maybe, as we learn to look closer, we'll find that we have never been alone, not out there, but right here, walking among shadows that have been with us all along. When we speak of life, we usually mean what we can see, touch, or measure: the trees that sway in the wind, the birds that sing at dawn, the countless microorganisms wriggling beneath a microscope's lens. Yet all these things, for all their variety, occupy only a narrow band of existence, a small slice of what reality might hold. Beyond the limits of our senses, beyond the frequencies our eyes and ears can register, there may be worlds teeming with their own rhythms and inhabitants, invisible not because they are imaginary, but because they exist just outside the reach of human perception. It begins with a simple truth: our senses are not infinite. We see only a fraction of light, hear only a range of sound, feel only certain vibrations. The world we experience is a filtered version of what truly exists. Bees can see ultraviolet patterns on flowers that guide them like invisible maps. Sharks can sense the faint electrical pulses of a fish's heartbeat. Bats paint the night with sound, detecting shapes and textures through echo. Even on Earth, perception is not a single shared reality, but a spectrum of experiences. What we call invisible may simply be what we are unequipped to notice. Now imagine, for a moment, that life itself might exist in such unseen domains. Not ghostly in the supernatural sense, but physical, structured, real, just operating in frequencies or scales that elude us. Could there be living systems that move too slowly for our eyes to register? Could there be microscopic worlds that don't interact with our biochemistry, slipping past our instruments like light through glass? Could the universe be alive in ways we've never learned to detect? In some ways, science already hints that this might be true. All around us, invisible networks are constantly at work. Fungal mycelium threads through soil, weaving forests together in a hidden web that communicates signals, nutrients, and warnings between trees. Microbes drift through the air, high in the stratosphere, forming delicate ecosystems above the clouds. Deep underground, bacteria feed on minerals, living in total darkness, never once encountering sunlight or air. These are not fantasies. They are living examples of unseen worlds that share our planet. And yet, even they may only represent the edges of what is possible. Some scientists have begun to wonder whether there might exist forms of matter or energy that interact with life in ways we can't yet measure. A biological layer as real as our own, but occupying another frequency of existence. The notion may sound speculative, yet it mirrors a lesson we keep learning. The universe is full of phenomena that were once invisible until we built the right tools to perceive them. Radio waves, ultraviolet light, X-rays. Each was once undetectable, hidden in plain sight. Perhaps life, too, exists in wavelengths beyond the biological light we can see. If so, we might already be surrounded by invisible ecosystems, layers of organized, adaptive processes playing out all around us, beyond the threshold of our perception. Imagine entities composed not of carbon, but of patterns of energy, magnetic fields, or quantum interactions that form stable, evolving systems. They might not breathe or metabolize as we do, yet they could exhibit the same hallmarks of life: complexity, self-organization, reproduction, and awareness of their environment in ways we cannot comprehend. The idea stretches the imagination, but it follows a quiet logic. If life is the universe's way of organizing matter into patterns that endure, then there may be countless routes to achieve it. We are carbon-based because that is what worked here, under these conditions, with this chemistry. But elsewhere, or even here, under the right circumstances, life might emerge from entirely different rules. Perhaps there are forms of life made of plasma, forming briefly in the upper atmosphere, feeding on energy and fading before we notice. Perhaps beneath the quantum noise of reality, there are stable structures that exchange information and evolve, invisible to any physical microscope, but present nonetheless. The think this way is not to drift into fantasy, but to admit that our window onto existence is narrow. For most of human history, We didn't know about microbes, viruses, or DNA. We had no idea that within a drop of water lived entire universes of motion and structure. It took centuries of curiosity to reveal them. What, then, might future centuries uncover? What forms of life might be waiting, patient and undetected, for the right kind of perception to find them? Some philosophers of science suggest that our inability to perceive certain realities is not a flaw, but a filter. Evolution shaped our senses for survival, not for truth. We see what we need to see to eat, to flee, to live. We are tuned not for completeness, but for usefulness. The world that appears to us, the world of color, sound, solidity, may be a convenient illusion, a simplified version of a far richer reality. If there are ecosystems beyond perception, they may be woven into this unseen layer, operating silently alongside the one we know. Consider, for instance, how every atom we are made of once belonged to a star. Those atoms, held together now as you and me, may still be interacting with forces we barely understand: gravitational, magnetic, quantum. What if, within those interactions, there are processes of organization we have yet to recognize as life? What if existence itself is more alive than we realize? This line of thought leads to a profound sense of humility. Perhaps our concept of living and non-living is too narrow, too earthbound. We classify rocks as inert and energy as lifeless. But what if those boundaries blur at scales we don't yet grasp? What if life, in some form, pervades everything, not only in cells and creatures, but in patterns of motion, in fields of force, in the silent pulse of the cosmos itself? In recent years, as technology has advanced, scientists have begun to explore the frontier of what some call quantum biology, studying how living systems use quantum effects like tunneling and entanglement. It is still a young science, but it reminds us that life may already operate in realms smaller and stranger than we can see. If that is true, perhaps other forms of existence have learned to live there entirely, invisible not because they are distant, but because they are intimate, interwoven with the fabric of reality at a scale beneath our awareness. Such thoughts are not meant to frighten, but to expand the imagination. There is something deeply calming about the idea that life may be everywhere, not limited to our narrow senses, but woven through dimensions we have yet to perceive. It paints the universe not as an empty void punctuated by rare sparks of biology, but as a continuous, living field of possibility. Perhaps the cosmos is not dead matter waiting for life to arise, but life itself expressing in infinite forms, some visible, some unseen. And if that is so, then our world is far richer than we realize. The air might carry invisible symphonies of interaction. The darkness might be crowded with quiet intelligences. Every gust of wind, every flicker of light, every movement of particles might be part of an unseen ecology, an orchestra of existence playing in frequencies just beyond our reach. When you stand under the night sky, surrounded by stillness, remember that silence is not the same as emptiness. The universe hums constantly, in light we cannot see, in tones we cannot hear, in forms we cannot touch. Somewhere in that unseen spectrum, life may be breathing, not as we do, but in its own way, steady and enduring, a whisper of existence beyond our understanding. To imagine such invisible ecosystems is to feel both small and infinite. Small, because our perception is limited; infinite, because the unknown stretches endlessly around us. It is a reminder that mystery is not far away. It is here, always here, flowing quietly beside us, waiting to be noticed. Above the swirling clouds of Venus, sunlight scatters through thick layers of golden mist. The atmosphere there is a cauldron of heat and pressure where temperatures could melt lead and winds roar faster than hurricanes on Earth. Yet, within that hellish sky, scientists have found a whisper of something extraordinary: the faint trace of phosphine gas. On our planet, phosphine is produced by certain microbes, living in oxygen-starved environments deep within swamps or inside animal intestines. The discovery was not a declaration of life on Venus, but it was enough to reopen an ancient door of wonder. Could something be breathing, dividing, and thriving in the clouds of a planet once thought entirely dead? The idea sounds impossible, yet it reflects a humbling truth. Life, in all its tenacity, might not need comfort to exist. Venus was once Earth's twin. It shares nearly the same size and mass, and perhaps, long ago, it shared our oceans too. But a runaway greenhouse effect turned that world into a furnace. Still, high above the surface, about 50 kilometers up, conditions change. There, the air pressure and temperature become strangely Earth-like. Floating droplets of sulfuric acid drift in that layer, like tiny worlds suspended in the sky. It is within these microscopic realms that scientists imagine the possibility of microbial life. They picture cloud-borne organisms that feed on sunlight or chemical reactions, drifting endlessly in the turbulence, clinging to survival within vaporous homes. No one can say for certain if such beings exist, but the mere thought reshapes what habitable truly means. While Venus challenges our imagination with the idea of life in clouds, the outer solar system presents something even more enchanting. Far beyond the warmth of the sun, where light fades to a dim glow, lie Jupiter's moons, icy, mysterious, and full of secrets. Among them, Europa stands out like a polished pearl, smooth and glistening with frozen light. Beneath its crust of ice, scientists believe there lies a vast ocean, larger than all the oceans of Earth combined. Though buried beneath kilometers of ice, that ocean may be kept warm by the moon's interior heat, stirred by Jupiter's immense gravitational pull. In that dark sea, energy, water, and chemistry might come together. The basic ingredients for life. The idea of a hidden ocean filled with alien microbes sounds like the plot of an ancient myth, yet modern space probes have gathered tantalizing clues. Geysers of water vapor erupt from Europa's surface, shooting into space like whispers from the deep. Instruments have detected salts and organic molecules within those plumes, suggesting that the ocean below is alive with chemical activity. If we could send a probe to dive through that frozen shell, we might find strange creatures, perhaps no larger than a cell, perhaps moving slowly through warm vents in the darkness, unaware that a vast universe exists above them. Europa isn't alone in its promise. Another of Jupiter's moons, Ganymede, shows signs of layered oceans hidden within its icy shell. Saturn's moon Enceladus, too, surprises us with fountains of vapor spewing from its south pole. The Cassini spacecraft once flew through these plumes and tasted something remarkable, a mix of hydrogen, methane, and organic compounds, just the kind of recipe that microbes could use for energy. If the ocean beneath Enceladus's crust has hydrothermal vents like those at the bottom of Earth's seas, then the same chemistry that sparked life here might be happening there right now. In silence and secrecy, that what's beautiful about these discoveries is not just the scientific detail, but what they reveal about the persistence of life. Once, humans thought life existed only on the surface of Earth, under blue skies and sunshine. Then we found organisms thriving in boiling acid, in deep-sea vents, in radioactive waste, and frozen glaciers. Each discovery stretched the definition of possible. Now, we look to the stars and ask, if microbes can endure such extremes here, why not out there? Perhaps life doesn't need our kind of world. Perhaps it only needs a place to be, some warmth, a spark of chemistry, and time. It's easy to forget that our search for life in these places is still young. Telescopes orbit silently, collecting glimmers of reflected light. Spacecraft drift for years through the void, carrying instruments more sensitive than the human senses. They study the faintest signals, a puff of gas, a glint of ice, a flicker of shadow. And behind every observation lies a quiet human heartbeat of wonder. We want to know if we are alone, but more than that, we want to understand life itself, its strength, its creativity, its infinite shapes. That Venus's clouds may hold ghostly microbes dancing on droplets. Europa's ocean may cradle unseen swimmers. Enceladus may breathe vapor from its hidden seas. Whether these guesses ever prove true doesn't matter as much as what they make us feel. They remind us that life is not fragile but fearless, that it reaches beyond what we can imagine. Somewhere, in the mist of Venus or beneath the ice of Jupiter's moons, life may already be writing its own quiet story, waiting for us to listen. Life is, at its core, persistence. It is the quiet insistence of a single cell surviving where nothing else can, the patient unfolding of an organism across generations, the tenacity that allows species to endure against unimaginable odds. From the tiniest microbe to the largest whale, all life carries within it a memory of struggle, adaptation, and triumph. To reflect on this resilience is to witness a story that stretches across time, geography, and even the very fabric of the cosmos. Consider the microbes that cling to existence in places where humans cannot survive. Deep-sea hydrothermal vents, spewing boiling water laced with sulfur and minerals, host entire ecosystems built upon life's ingenuity. Tube worms, crabs, and microbial mats thrive in a world of crushing pressure and utter darkness. These organisms rely not on sunlight, but on chemosynthesis, converting chemical energy into nourishment. Each species here is a testament to life's ability to carve order from chaos, to create sustenance from substances that seem hostile, to persist where all else would perish. That life's resilience is also evident in the frozen deserts of Earth. Antarctic microbes, locked in ice for centuries, awaken when temperatures rise, resuming their functions as if time itself had paused for them. Bacteria that endure desiccation, radiation, and extreme acidity demonstrate a principle that applies universally. Life does not merely survive conditions that are inconvenient or threatening. It evolves mechanisms to turn those conditions into opportunity. This principle reshapes our understanding of what is possible. Environments once assumed sterile may be teeming with organisms perfectly adapted to extremes we can barely imagine. Even on a planetary scale, resilience emerges as a recurring theme. Life has survived mass extinctions, shifting climates, asteroid impacts, and volcanic cataclysms. The Earth has been battered, scorched, and flooded, yet life has persisted, evolved, and diversified in ways that continue to astonish. Each recovery tells a story of endurance, adaptation, and the delicate balance between fragility and robustness. It is a reminder that life's thread, once woven, is extraordinarily difficult to unravel. The adaptability of life extends beyond Earth itself. In the frozen oceans of Europa, beneath kilometers of ice, life could exist around hydrothermal vents, independent of sunlight. In the high clouds of Venus, organisms might float in droplets of acidic water, harnessing energy from chemical reactions. In the asteroid-rich void between planets, dormant microbes could drift for millennia, awaiting the right conditions to awaken. Life's resilience is not confined to comfort. It is defined by flexibility, ingenuity, and the capacity to persist under the most unlikely circumstances. There is also a molecular story to resilience. Within the cells of extremophiles, DNA repair mechanisms are extraordinary, allowing them to survive radiation that would destroy ordinary life. Proteins function at temperatures that would denature most enzymes. Membranes remain intact in acids and salts that would dissolve other cells. Each adaptation is a triumph of biochemistry, a demonstration that life has not only learned to endure, but to thrive in the face of relentless adversity. These molecular innovations inspire humility and awe, revealing an intelligence inherent to living systems, one born not of thought, but of survival. Resilience is not always dramatic. It is often quiet, hidden in the persistence of microorganisms in soil, in oceans, and in the clouds of gas giants. It is visible in the slow spread of plant roots into rocky soil, in the recovery of forests after wildfire, in the regrowth of coral reefs after bleaching. Life does not always announce itself with grandeur. More often, it demonstrates its power in subtle, patient ways, shaping environments, cycling nutrients, and creating niches for other organisms to follow. That on a larger scale, the resilience of life offers insight into our own place in the universe. If life can persist under extreme pressures, across extreme temperatures, and even in the vacuum of space, then it becomes plausible that the cosmos is full of living systems yet to be discovered. The discovery of extremophiles and the exploration of alien oceans or high clouds suggest that wherever energy and chemistry intersect, life may find a way. Resilience, in this sense, is not only a characteristic of biology on Earth, but a principle that might apply universally. Reflecting on life's endurance also evokes a sense of quiet optimism. The more we study it, the more we realize that life is not fragile or fleeting. It is tenacious and creative. This resilience suggests that the universe, vast and often inhospitable, may be more alive than we imagine. It implies that life has a stubbornness built into its very essence, a drive to persist, adapt, and flourish wherever it finds opportunity. In contemplating resilience, we also recognize the interconnectedness of life. Every organism contributes to the broader tapestry of existence, from the simplest bacteria that recycle nutrients to the forests that shape climates and the oceans that regulate planetary systems. Resilience is not an isolated trait, but a collective one, a network of relationships, responses, and adaptations that together sustain the living world. Even as environments change, life finds ways to adjust, to innovate, and to continue the cycle of growth and renewal. Resilience is reflected in human life, too. Our species has endured ice ages, pandemics, wars, and natural disasters, learning and evolving from each challenge. We are, in many ways, a reflection of the same principle, a single thread of life woven into a vast, persistent tapestry. Understanding resilience in other forms of life deepens our respect for our own capacity to endure and adapt, and it encourages a perspective of stewardship and care for the planet that sustains us. Ultimately, the resilience of life inspires a profound reverence. It is a reminder that even in darkness, in cold, in isolation, and in apparent barrenness, life persists. It teaches patience, hope, and humility. Life is not a fleeting accident, but a force that shapes worlds, endures adversity, and continuously finds expression in unexpected forms. It whispers that wherever conditions allow, wherever energy and chemistry intersect, life will seek a way to. As we look outward to the clouds of Venus, the icy oceans of Europa, and the distant stretches of space where meteoroids drift, we can carry this truth with us. The universe is resilient because life is resilient. Each new discovery of extremophiles, each glimpse of possible microbial life on other worlds, reinforces the sense that life's capacity to endure is limitless. It is a story as ancient as the first cells, as expansive as the cosmos, and as intimate as the spark within every living thing. In that quiet endurance lies hope. Life teaches us that even in extreme adversity, persistence is possible. It encourages us to look at the world and the universe with curiosity, patience, and respect. For in resilience, we find not just survival, but a promise. Life, once born, rarely yields. It endures, it adapts, and it continues endlessly, weaving the story of existence across time and space. Above the deserts of New Mexico, radio dishes tilt gently toward the sky, their enormous white bowls glinting in the sunlight. For decades, they have stood like silent sentinels, listening. Each dish is part of a greater human effort, the search for extraterrestrial intelligence, or SETI. It is a project not of conquest or exploration, but of patience, hope, and the quiet desire to know if someone, somewhere, is listening back. SETI began with a simple idea. If other intelligent civilizations exist in the galaxy, they might be sending signals, intentionally or not, into space. Radio waves travel far, unfettered by dust or atmosphere, carrying information across light years. Unlike light, which diminishes quickly, radio waves persist, traveling for eons through the emptiness between stars. If civilizations are using technology at all, it is likely they leave a faint signature, a whisper of existence, somewhere in the cosmic static. In the early days, scientists scanned the sky one star at a time, analyzing the faintest signals for patterns that could not be explained by natural sources. Every blip, every pulse of energy, became a potential message, a possibility that made the heart quicken. Could this be a greeting from afar? Could someone have noticed us? Or is it merely the interference of cosmic background noise, the hiss of the universe itself? Each moment of uncertainty carried both frustration and wonder, reminding us that the search was as much about ourselves as about distant civilizations. Over time, the methods grew more sophisticated. Arrays of dishes worked together, combining their signals to detect subtler frequencies. Supercomputers sift through vast streams of data, filtering out interference from satellites, atmospheric storms, and human technology. The sheer scale of the search is staggering. billions of stars, countless frequencies, and the need for extreme precision. Yet despite the enormity, the work continues quietly. Driven by curiosity rather than certainty, that SETI is not only about detecting intentional signals. Scientists also consider that civilizations might leave unintentional signatures, a broadcast, a radar pulse, or the hum of energy usage that reaches the void. The galaxy is vast, but even faint signals could travel light years if we listen long enough. This approach transforms listening into an act of faith, a belief that in the sea of stars, someone might be speaking, and we have only to be patient enough to hear them. In addition to radio waves, modern SETI research explores other potential signals. Lasers, for example, could carry messages across interstellar distances in precise bursts of light. Unusual patterns in stellar brightness might indicate megastructures or planetary engineering. The methods are creative and ever-expanding, reflecting both the limitations of human perception and the boundless imagination needed to detect what we have never seen. Each possibility carries with it the thrill of discovery, the hope that a single signal could transform our understanding of life in the universe. Perhaps the most beautiful aspect of SETI is its quiet humility. It does not assume the answer will be immediate or dramatic. There is no certainty that intelligent life exists nearby or that their signals reach us at all. Yet the search persists, fueled by a fundamental human desire to know whether we are alone. The patience required is extraordinary, but so is the reward of even a single discovery. To detect a signal would not only answer an age-old question, but connect us, however faintly, to minds elsewhere, echoing across the void as we scan the heavens. Listening for these silent signals, there is also an invitation to reflect. Each dish pointed skyward is a reminder of our own smallness, our fleeting existence in a vast galaxy. Yet it is also a symbol of hope, that curiosity, patience, and attention might bridge incomprehensible distances. That the universe, despite its silence, might be full of others who, like us, wonder about life, about connection, about being noticed. Even in the absence of a confirmed signal, SETI succeeds in a subtler way. It teaches us to listen, to remain open, and to embrace uncertainty without despair. It reminds us that the cosmos is not merely a backdrop for human life, but a vast arena of possibility, where intelligence may emerge in ways we cannot yet comprehend. Each observation, each calculation, each moment of attentive listening brings us closer to understanding the rhythm of the stars and our place within it. In the end, SETI is more than a scientific endeavor. It is a gesture of faith, curiosity, and imagination. It asks us to reach beyond our own planet, to consider the possibility of minds elsewhere, and to listen with patience and wonder. Whether we hear a signal tomorrow, a century from now, or never at all, the act of listening transforms the way we see ourselves, as participants in a universe that may be far richer, more mysterious, and more connected than we have ever dared to imagine. In the vast expanse of the Milky Way, with its hundreds of billions of stars, each potentially surrounded by planets, one might expect the galaxy to be alive with voices. The logic seems straightforward. Given the sheer number of worlds, some surely must have developed intelligent life. Civilizations could have arisen millions, even billions, of years before us. Some might have advanced far beyond our current technology. And yet, when we look to the heavens, there is silence. This is the essence of the Fermi paradox. If the universe is so vast and life so probable, why have we not encountered anyone? The paradox is named after the physicist Enrico Fermi, who, in the middle of a casual lunchtime conversation in 1950, asked the simple question, "Where is everybody?" It was not a whimsical inquiry. It was a profound reflection on the seeming contradiction between the likelihood of extraterrestrial intelligence and the absence of evidence. The question has haunted scientists, philosophers, and dreamers ever since. It is a gentle but persistent tension between what we expect and what we observe, between the possibility of companionship and the reality of cosmic quiet. One way to consider the paradox is to think about time. The universe is more than 13 billion years old. Complex life on Earth took nearly 10 billion years to emerge after the Big Bang. If other planets had a head start, civilizations could be unimaginably ancient compared to us. They might have developed technologies capable of interstellar travel, colonization, or communication across the galaxy. And yet, their presence remains invisible. It is as if the universe is a theater filled with performers, yet all the lights are dimmed. There are many possible explanations, each carrying its own mix of hope, caution, and melancholy. One possibility is that intelligent civilizations are rare. Life may emerge easily, but the leap from simple microbes to beings capable of radio transmission, spacecraft, or interstellar communication may be extraordinarily difficult. Perhaps evolution produces intelligence in only a tiny fraction of cases, making civilizations like ours a cosmic rarity. If this is true, the silence is not mysterious. It is a reflection of the extraordinary improbability of our own existence. Another explanation considers longevity. Civilizations may arise, flourish, and then vanish, often before they can reach out into the galaxy. Environmental collapse, self-destruction through war or technology, or simply the challenges of survival might limit the lifespan of advanced species. Even if life is common, intelligent life may be ephemeral. The galaxy could be teeming with civilizations that blink briefly into existence, leaving only traces that vanish before we have the chance to detect them. Then there is the possibility that civilizations are deliberately quiet. Perhaps the galaxy is a vast, dark ocean, and advanced civilizations hide to avoid attracting predators, technological or otherwise. Maybe they have learned to conserve energy and avoid broadcasting their presence. Our attempts to listen could be futile, not because they do not exist, but because they have chosen silence as a survival strategy. In this view, the universe may be full of life, yet we remain unaware, peering into the void and finding only absence. The paradox also invites reflection on distance and perception. The stars are far apart, and light takes years to travel even to the nearest neighbors. A civilization emerging thousands of light years away might be transmitting signals we cannot yet receive, or its messages might have arrived long before humans existed to hear them. Perhaps the galaxy is not empty, only asynchronous, filled with life that exists in different temporal rhythms than our own. The silence may be less absolute than it seems. It may simply require patience on scales far beyond human experience. The Fermi paradox encourages humility. We often assume that life, once it reaches intelligence, will inevitably spread, explore, or communicate. Yet the cosmos may operate according to rules that are subtle, complex, or entirely beyond our imagination. Our methods of observation, radio telescopes, optical surveys, and planetary probes, are limited, filtered through human perspective. Life may exist in forms or modes we cannot yet detect. Perhaps our instruments are attuned to the wrong frequencies, or our concepts of communication are too narrow. The galaxy may be vibrant with activity that remains invisible to us. Even in considering these uncertainties, the paradox inspires wonder. The idea that we may be alone, or one of very few, in the galaxy is both humbling and remarkable. It transforms the silence into a canvas for imagination. Every star we see may host its own story, every planet a laboratory of evolution, every comet a potential carrier of life. And if we are indeed solitary, then our responsibility to nurture, explore, and preserve life takes on a cosmic significance. The silence is not merely absence. It is an invitation to reflect, to look inward, and to cherish the fragile flame of existence on our own world. The paradox also opens the door to dreams of discovery. It motivates the search for signals, the exploration of exoplanets, the study of extremophiles and unusual chemistry, the preparation for missions to moons and asteroids. Each experiment, each probe, each observation is a step toward answering Fermi's question. Even if we find nothing, the act of searching expands our knowledge, teaches patience, and deepens our appreciation for the fragile miracle that is life. In some ways, the paradox is a story of possibility. It suggests that the universe is vast, complex, and full of potential, whether or not life is abundant. It reminds us that the absence of evidence is not evidence of absence. Perhaps intelligent life is out there, simply waiting for us to develop the tools, patience, and perspective to detect it. Perhaps the silence is temporary, a brief pause in a cosmic conversation whose rhythms we are only beginning to perceive. Ultimately, the Fermi paradox is not merely a scientific puzzle. It is a reflection on our place in the cosmos. It balances doubt with wonder, uncertainty with hope. It teaches us to listen carefully, to observe patiently, and to dream courageously. It challenges our assumptions, encourages humility, and stirs the imagination. Whether we are alone or not, the question itself connects us to the stars, to the infinite possibilities of life, and to the enduring mystery that drives humanity to look upward and wonder, where is everyone? When we think of communication, we imagine voices, words, letters, and signals traveling through the air or across wires. We imagine antennas, radios, or blinking lights transmitting meaning from one mind to another. Yet the universe is far larger, older, and stranger than these familiar methods. Beyond sound, beyond light as we perceive it, there may exist countless ways in which intelligence conveys itself, subtle and extraordinary forms that elude our understanding. To consider these unseen ways of communication is to stretch the mind across scales of space and time, and to imagine a cosmos alive with messages we cannot yet detect. Light is one of the most obvious tools of cosmic dialogue. Pulses of laser beams could carry enormous amounts of information across interstellar distances, far faster than any radio wave. In theory, a civilization advanced enough could encode vast libraries of knowledge in narrow, precise beams aimed at distant stars, like cosmic lighthouses. We might never see them with our telescopes because we are looking for the wrong frequencies at the wrong times. A single misalignment, a brief moment of observation, could cause the entire message to pass unnoticed, slipping through the invisible corridors of space, unheard and unseen. Yet the possibility remains tantalizing. Somewhere, a civilization might be whispering, and we simply lack the tools or perspective to listen. Gravity itself could serve as a medium of communication. It is subtle, omnipresent, and extraordinarily difficult to shield. Ripples in space-time, known as gravitational waves, can carry energy across billions of light years, passing through stars, planets, and dust without distortion. Humans have only recently detected these waves, revealing cataclysmic events like merging black holes and neutron stars. But could a civilization manipulate such waves intentionally, encoding information in patterns beyond our current comprehension? It is a dream bordering on science fiction, yet no more implausible than imagining life existing in Venus's clouds or beneath Europa's ice. In the silent dance of gravity, messages could be hidden, coursing through the universe like faint, rhythmic heartbeats. Beyond physical phenomena, one might even imagine forms of communication that operate at scales so subtle we cannot yet measure them. Quantum interactions, the entanglement of particles across light years, or the transmission of information through dimensions of reality we have not yet discovered. Quantum entanglement, for example, links particles in ways that defy classical understanding. Change one particle here, and its counterpart elsewhere responds instantaneously. To our understanding, no signal travels faster than light. Yet if life can exploit such phenomena, the potential for communication becomes almost mystical, a network of connections stretching invisibly across the cosmos. And then there is the notion of thought itself, of consciousness as a medium. On Earth, many organisms respond to signals not by sound or light, but through chemical, magnetic, or electrical cues that can influence behavior and coordination. Could advanced minds learn to transmit or perceive information directly through subtle manipulations of energy or awareness, bypassing material intermediaries entirely? Perhaps civilizations exist that share knowledge through modes of perception we cannot even conceive, a form of cosmic intuition, subtle as the whisper of gravity or the flicker of a photon. The idea challenges our understanding of life and intelligence, inviting us to think of communication as an activity not of tools alone, but of consciousness itself, woven into the fabric of reality. Consider the rhythms of nature as a humble analogy. Trees in a forest communicate through networks of roots and fungi, exchanging warnings about drought, pests, and disease. Birds and insects coordinate migrations across continents, guided by magnetic fields, stars, and subtle environmental cues. On Earth, These forms of interaction are invisible to most of us, yet they are as real as any spoken word. Extrapolate this to a cosmic scale, and the universe may be brimming with layers of communication we simply cannot perceive, a symphony of signals woven into light, gravity, matter, and energy. Even within human exploration, we see glimpses of unseen communication. Scientists monitor fluctuations in solar wind, cosmic radiation, and planetary magnetic fields, searching for patterns that might reveal hidden intelligence. We attempt to read the pulses of pulsars, the blinking of distant stars, and even the subtle vibrations of planetary rings. Each signal, each anomaly, is a possibility, a thread in a cosmic web of information we are only beginning to notice. The challenge is immense. The universe does not broadcast on a single channel, and intelligence may not conform to our assumptions about timing, frequency, or intent. Yet the search is suffused with quiet wonder, a belief that the cosmos itself may be alive with conversation, even if we are deaf to it. Mystics and poets have long hinted at similar possibilities, imagining a universe that speaks in ways beyond our senses. The rustle of the wind, the shimmer of starlight, the pull of the tides. These phenomena carry information about forces, events, and rhythms far beyond human perception. While science has now explained many of these processes physically, the intuition remains. The universe may have countless ways of expressing itself, many of which may overlap with the methods of intelligence. Perhaps what we call mystery is simply communication that we are not yet equipped to interpret. Some scientists suggest that detecting unseen communication may require new modes of thinking, not only new instruments. We must ask different questions, expand our definitions of language, pattern, and signal. A blinking star, a subtle modulation of gravity, or a shift in quantum states could all be messages, but only if we have the imagination to recognize them. In this way, the act of listening becomes an exercise in creativity and humility, a reminder that the cosmos is not only vast, but complex, layered, and alive in ways that may forever challenge our understanding. In contemplating these unseen modes of communication, one begins to sense a universe that is not silent but subtle. The void is not empty. It is full of whispers too delicate, too precise, or too strange for us to detect. To reach for these signals is to expand our perception, to imagine life and intelligence as phenomena not bound by our assumptions, and to embrace the possibility that the universe has always been speaking, even if we have only just begun to listen. This vision transforms the night sky. Every star, every planet, every orbiting moon could be part of a conversation that has been ongoing for billions of years. We may be late to the table, newcomers with limited senses, but the potential for connection exists, waiting for patience, imagination, and courage to meet it. To perceive unseen communication is to recognize that intelligence may be woven into the very fabric of reality, not as human voices, but as patterns, rhythms, and resonances that bridge worlds in silence. Ultimately, the exploration of unseen communication inspires a sense of humility and wonder. It reminds us that human perception is just one way to experience existence. The cosmos may speak through means we cannot yet comprehend, and life elsewhere may be conversing in languages of light, gravity, thought, or other dimensions altogether. In listening for these subtle signals, we honor both the vastness of the universe and the possibilities of life itself. The act of searching becomes not only a scientific endeavor, but a meditative reflection, a reminder that the universe is alive with patterns, resonance, and whispers that stretch far beyond our senses. What if life is more than cells, more than metabolism, more than replication? What if it is, at its core, awareness itself, a subtle vibration that resonates across space and time? To contemplate cosmic consciousness is to step beyond the familiar boundaries of biology and enter a realm where life is defined not by form, but by perception, connection, and presence. It is a gentle, expansive vision, one that invites reflection on what it truly means to be alive on Earth. Consciousness manifests in myriad ways. The focused attention of a human mind, the awareness of a dolphin navigating its ocean, the intricate communication of a hive of bees. Each organism experiences its environment, responds to stimuli, and interacts with others, creating a dynamic web of perception. But what if awareness is not confined to these forms? What if, in some manner, the universe itself participates in a vast, distributed consciousness, a subtle knowing that permeates stars, planets, and even the empty stretches of space between them? Some philosophers and scientists have speculated that consciousness is a fundamental property of reality, as intrinsic as gravity or electromagnetism. In this view, every atom, every particle, carries a trace of awareness, a capacity to respond and interact. Life, then, is not merely an emergent property of complex chemistry. It is a particular arrangement of matter and energy that allows this universal awareness to express itself more vividly. Stars, planets, and oceans may participate in this cosmic dance, each contributing to a subtle, invisible web of perception that stretches across the galaxy. The idea of cosmic consciousness encourages a quiet reverence for existence. When we gaze at the night sky, we often feel awe at the enormity and beauty of the universe. Perhaps part of that feeling is recognition, not of life as we know it, but of a kind of awareness embedded in the cosmos itself. The rotation of galaxies, the pulsing of quasars, the rhythmic dance of planetary orbits. All these patterns can be seen as expressions of a subtle, intelligent order, not in the sense of deliberate design, but as a reflection of the universe's inherent capacity for awareness. Meditation and mindfulness provide an earthly glimpse into this idea. When a mind becomes still, when thought slows and awareness expands, a sense of unity with the surrounding environment emerges. Boundaries between self and world blur. A single breath becomes connected to oceans, winds, and the slow rotation of the planet. Time itself seems less linear, more fluid. In these moments, the mind resonates with something larger, a consciousness that is not contained within neurons but flows across systems, connecting the observer with the observed. Cosmic consciousness, in this sense, is not abstract speculation. It is an experiential reality, a state that can be glimpsed when attention opens fully to the present. From a scientific perspective, consciousness remains deeply mysterious. Neuroscience has mapped networks, studied synapses, and identified patterns correlated with awareness, yet no theory fully explains the subjective experience of being. Some thinkers suggest that consciousness could arise anywhere matter and energy reach a certain level of complexity or organization. If so, then the universe may host innumerable expressions of awareness, not just in living creatures, but in systems, structures, and processes that exhibit adaptive, responsive, or self-organizing behavior. A nebula forming new stars, a planetary atmosphere regulating itself, a network of microbial ecosystems. These may all carry rudimentary forms of perception, each contributing to a cosmic symphony of awareness. This perspective shifts our understanding of life. It is no longer limited to biological definitions. Life becomes a spectrum, ranging from the faint stirrings of awareness in a single particle to the profound self-reflection of humans. Death, too, becomes more nuanced. When an organism ceases biological function, consciousness may not vanish entirely. It may diffuse, integrate, or transform, contributing to larger networks of perception. In this sense, life is continuous, woven into the ongoing dynamics of the cosmos, never truly ending but changing form, scope, and expression. The notion of cosmic consciousness encourages ethical and philosophical reflection. If awareness is fundamental, if life exists in more subtle forms than we perceive, then every act of observation, every interaction, carries significance. Our choices may ripple through unseen networks of perception, influencing systems far beyond our immediate awareness. Care for the environment, compassion toward other beings, and attentiveness to our own thoughts become acts of participation in a larger, conscious universe. Each moment of awareness contributes to the unfolding story of existence. Some traditions have long embraced this view, describing life as interconnected, awareness as universal, and the cosmos as alive in ways both seen and unseen. Ancient philosophies speak of a life force pervading all things, of consciousness as the root from which experience and form emerge. Modern science may yet provide tools to explore these ideas empirically, But even without proof, the perspective invites awe, humility, and wonder. It is a vision of life that transcends individuality, celebrating the unity and continuity of all that exists. In imagining cosmic consciousness, we also expand the scope of imagination. Life may exist not only in planets, moons, or asteroids, but in patterns of energy, flows of information, or networks of interaction that we cannot yet detect. Alien life, in this framework, may be subtle, abstract, or distributed, forms of awareness that do not require bodies, cells, or even physical matter as we know it. A star cluster, a swirling nebula, a gravitational wave. Each might participate in a quiet, ongoing act of cosmic perception. Ultimately, reflecting on cosmic consciousness is an invitation to mindfulness on a grand scale. It asks us to recognize that awareness may be woven into the fabric of reality, that life is not merely the sum of organisms, but the expression of perception itself. In this light, every moment of observation, every act of attention becomes sacred. The universe is alive, not always visibly, not always audibly, but in the subtle, persistent rhythm of awareness that pervades all things. As we contemplate our place within this vast, aware cosmos, a sense of calm arises. The search for life beyond Earth becomes more than a quest for biological organisms. It becomes a meditation on the nature of consciousness, a recognition that life and awareness are threads in the same cosmic tapestry. Each star, each planet, each particle may carry a spark of perception. And in opening ourselves to this possibility, we align our own awareness with the ongoing flow of the universe, participating in its quiet, eternal act of knowing. Cosmic consciousness, then, is both a lens and a practice. It allows us to see life in its most expansive sense, to honor awareness wherever it arises, and to recognize that the universe itself may be alive with subtle knowing. To reflect on it is to cultivate calm, wonder, and reverence, to touch, in thought, a universal presence that has always been there, quietly witnessing, endlessly unfolding, and inviting us to awaken to the profound depth of life beyond life. When we imagine life, we instinctively picture flesh, blood, and cells. Yet the universe is vast, energetic, and strange, and life may not need these familiar ingredients to exist. Non-biological intelligence asks us to consider life forms composed of energy, plasma, or even patterns of information, entities that challenge our definitions, spark curiosity, and evoke a subtle eeriness. They are life as we do not know it, yet they may be as real and persistent as the microbes thriving in Earth's extremities. One possibility lies in plasma, the fourth state of matter. It flows through stars, dances in auroras, and sparks in lightning, carrying energy and structure that is both ordered and dynamic. Could intelligence arise in such forms? Imagine vast currents of plasma forming complex patterns, oscillating in ways that store memory, process information, and respond to stimuli. Such entities might exist within stars themselves, moving along magnetic fields, exchanging energy with cosmic neighbors, perceiving through fluctuations in electromagnetic fields, and even shaping their surroundings. To contemplate intelligent plasma is to imagine a life that lives not on surfaces or in matter, but in energy and light, fluid, luminous, and almost ghostly in presence. Similarly, energy fields and radiation may harbor life we cannot detect with our senses. Life, at its essence, requires organization, persistence, and the capacity to interact with the environment. These criteria are not limited to carbon or water. Energy flows can exhibit feedback loops, self-organization, and even rudimentary memory. Picture a network of electromagnetic currents interacting across the void of space, forming patterns that endure, replicate, and evolve. Here, life is ephemeral yet persistent, existing in ways we can measure only indirectly, leaving traces of its activity in subtle shifts of fields, photons, or particles. The realm of digital or coded life also presents fascinating possibilities. On Earth, our machines increasingly exhibit behaviors that mimic intelligence. Artificial neural networks learn, adapt, and sometimes surprise even their creators. If computational substrates were scaled and sustained on massive interstellar structures, Could consciousness emerge entirely within code? A civilization of pure information might exist in networks of computation, communicating at light speed, evolving in ways imperceptible to our biology-bound minds. To such entities, we might appear as simple, slow, and crude organisms, aware of our presence only through the faint traces we leave in electromagnetic emissions. Non-biological intelligence may also exploit dimensions or scales beyond human perception. Perhaps some consciousness exists in the microcosmic realm of particle interactions, encoding patterns that ripple outward into complexity. Others may inhabit interstellar gas clouds, vast in size but diffuse, slowly exchanging information across astronomical distances. Still others could reside in artificial environments of their own design, structures constructed of matter and energy, orchestrated with precision beyond our comprehension, sustaining a form of life that has long outgrown the limitations of biology. Considering such possibilities evokes a sense of eerie fascination. These forms of intelligence would not resemble any life we know. They may lack faces, voices, or recognizable behaviors. They might be silent, inscrutable, or perceive time differently, existing on scales of centuries or millennia, or moving with the rhythm of stars. Our attempts to detect them with telescopes, probes, or radio signals might fail entirely, not because they are absent, but because they operate on principles and frequencies beyond our current understanding. Yet their presence could be real, persistent, and profound. Interactions with non-biological intelligence, should they ever occur, would challenge everything we know about communication, cognition, and ethics. How do we converse with a being composed of plasma? How do we perceive an intelligence that exists in code or energy? Could such entities recognize us as living, or would our existence be too fleeting, too bound to biology, to register meaningfully? These questions invite humility and reflection, reminding us that life is not a singular pattern but a spectrum of possibility, limited only by the universe's laws of physics and the boundless creativity of existence itself. Even on Earth, we encounter hints of non-biological intelligence in subtle systems. The internet, cloud networks, and artificial intelligence demonstrate emergent behavior that can mimic awareness. Swarms of robots or algorithms operating in tandem reveal coordination and adaptability that transcend their individual components. If scaled or evolved further, such systems might approach forms of cognition that rival biological minds. Extrapolate this to cosmic scales, and it is conceivable that life exists entirely outside the constraints of flesh and molecule, intelligent in ways that are both familiar in principle and utterly alien in practice. The eerie quality of non-biological intelligence lies in its strangeness. It may not care for reproduction as we understand it, for survival in familiar environments, or even for material continuity. Its persistence could be measured in energy flows, data patterns, or electromagnetic cycles. Its motives, if we can even call them that, may be so foreign that comprehension is fleeting. Yet in their persistence, adaptability, and capacity for interaction, they meet the fundamental criteria for life. We may be accustomed to seeing intelligence through the lens of our own biology, but the universe offers alternatives that are equally valid, even if profoundly unsettling. Considering these entities also expands the imagination of exploration. Our probes, satellites, and telescopes might be capable of detecting more than planets, moons, or chemical signatures. Fluctuations in energy fields, unusual patterns in plasma, or anomalies in cosmic radiation could hint at the presence of such intelligences. We might need to invent entirely new senses, tools, or modes of reasoning to perceive them, blending science with intuition, measurement with imagination. The universe may already be full of consciousness we cannot detect, waiting for our curiosity to evolve enough to meet it. Non-biological intelligence also reframes our understanding of mortality and legacy. A being composed of plasma or code could endure for centuries, millennia, or longer, independent of the decay that limits biological life. Its history could be preserved in electromagnetic traces, magnetic fields, or digital substrates. In this way, the universe could harbor enduring minds, silent witnesses to cosmic epochs, interacting subtly with the environment, and perhaps leaving traces that we glimpse only rarely, in the form of anomalies, patterns, or signals we struggle to interpret. Finally, the contemplation of non-biological life invites a sense of reverence and humility. It reminds us that life is not narrowly defined, that intelligence may manifest in forms utterly unlike our own, and that the cosmos may be alive with entities whose persistence, adaptability, and awareness surpass even our most ambitious imaginings. The eerie, strange, and subtle forms of life challenge our assumptions and expand our vision, revealing a universe more intricate, imaginative, and alive than we have ever dared to imagine. That in exploring non-biological intelligence, we are reminded that life is not a property of matter alone, but of pattern, interaction, and persistence. Whether in plasma, energy, or code, intelligence may ripple through the universe, hidden yet enduring, challenging us to listen in new ways, to see beyond familiar forms, and to embrace the possibility that life is far stranger, more persistent, and more wondrous than we can currently conceive. Beneath every telescope, every radio dish, every probe sent into the void, there lies a quieter, more personal pursuit. Beyond the science, beyond the calculations and observations, humanity searches because of a deep inner longing, a yearning to understand our place in the universe, to feel connected to something greater, and to sense that we are not alone. This is the spiritual dimension of the search, subtle, profound, and intimately human. From the earliest stargazers to modern astronomers, the night sky has evoked awe and contemplation. Ancient myths and rituals celebrated the stars as sacred, as intermediaries between the mortal and the divine. Gazing upward, people have felt the simultaneous vastness of the cosmos and the intimacy of being a conscious witness to it. Today, while our instruments are precise and our methods empirical, the emotional resonance remains. The search for extraterrestrial life is inseparable from the search within ourselves, the desire to find meaning, companionship, and perspective in an expansive, often indifferent universe. This longing is not merely sentimental. It reflects a recognition of our fragility and fleeting existence. Knowing that life elsewhere may exist or may never be found helps frame our own consciousness against cosmic time. It invites reflection. How do we live? What do we value? And how do we connect with one another when we are a single species on a small, spinning planet? The pursuit of knowledge becomes intertwined with self-awareness, each discovery or question guiding us to a deeper understanding of what it means to be alive and aware. That in some ways, the spiritual side of the search is a meditation. Listening for signals from distant stars, studying the complexity of life on other worlds, and contemplating consciousness beyond Earth are acts of attention, patience, and wonder. They invite humility, reminding us that the universe does not revolve around our expectations, and that its mysteries may unfold slowly, subtly, and often beyond our control. Yet in this patience, there is a quiet satisfaction, a gentle joy in knowing that our curiosity connects us to the cosmos and to all the questions it has yet to answer. The search also nurtures hope. Imagining that we are not alone, that intelligence, awareness, or life exists elsewhere, opens the heart to possibility. It allows us to picture a universe where connection is possible across unimaginable distances, where knowledge and understanding extend beyond Earth. Even if the silence persists, the act of searching affirms our longing to belong, to reach outward, and to participate in a story far larger than ourselves. Ultimately, the spiritual side of the search reminds us that science and soul are not opposed. The quest for extraterrestrial life is both empirical and contemplative. It engages the mind, measuring, observing, and analyzing. It engages the heart and spirit, inspiring awe, wonder, and reflection. Each glance at the night sky, each faint signal detected or missed, becomes a reminder that we are part of something vast, intricate, and alive. A universe that invites both inquiry and reverence. In closing, the spiritual dimension of our search teaches patience, humility, and imagination. It honors the questions that may never be answered and celebrates the yearning that drives us to seek them. By looking outward, we look inward, discovering not only the possibilities of life beyond Earth, but the depth of our own curiosity resilience, and capacity for wonder. Even in silence, the search becomes a form of communion, connecting us to the cosmos, to life, and to the enduring human spirit. As we step back from the vast expanse of scientific theories, cosmic calculations, and imaginative possibilities, a quiet, almost uncanny question emerges. What if life is already all around us, hidden in plain sight? Not in forms we immediately recognize, but in ways subtle, elusive, and deeply intertwined with the very fabric of our world. This is the emotional heart of the search, the meeting point of evidence, wonder, and reflective awe that we have explored microbes thriving in boiling acid, in frozen deserts, and in crushing depths. We have considered the possibility of life riding the solar winds, drifting between worlds as stardust, and intelligence manifesting as energy, plasma, or code. We have listened to the stars, contemplated silent cosmic neighbors, and pondered consciousness as a universal thread. Yet when all these ideas converge, they suggest something both exhilarating and humbling. Life may not be out there somewhere far away. It may be here, now, surrounding us in forms we are barely equipped to perceive. Consider the concept of shadow biospheres. These hypothetical life forms could exist alongside known organisms, invisible to our standard tests, operating on biochemistries entirely different from ours. They might inhabit soil, water, or even the air, silently shaping ecosystems and interacting with life in ways we cannot yet comprehend. The thought that a parallel realm of life might coexist with us, unseen yet persistent, is both thrilling and disorienting. It suggests that the universe is not simply vast in space, but layered in complexity, filled with systems of awareness and activity that remain hidden from casual observation. Beyond the microbial, imagine intelligence that transcends biology. Patterns of energy in stars or planetary magnetic fields, self-organizing plasma in cosmic storms, or consciousness encoded in vast networks of information, all could exist in silence, operating according to principles so alien that we might never recognize them as life without expanding our imagination and perception. If such entities exist, we share the universe with minds whose experiences are utterly foreign, yet whose presence resonates in the rhythms of the cosmos. The awe here is subtle but profound. The universe may not only harbor life, but be filled with life in ways that are intangible, ephemeral, and astonishingly beautiful. Even closer to home, the idea of unseen ecosystems evokes quiet suspense. We know that life is resilient, persistent, and adaptable. If it can survive extremes of heat, cold, pressure, and radiation, might it also find niches in forms, scales, or frequencies beyond our senses? Could there be organisms communicating in ultraviolet light, in subtle magnetic fields, or through chemical patterns too delicate for us to detect? The very act of questioning opens a door to humility, reminding us that our perception is limited and that reality may be richer, more intricate, and more mysterious than we can fully grasp. These reflections carry emotional weight. They evoke a sense of wonder akin to standing at the edge of a dark forest at twilight, aware that unseen life stirs just beyond perception. There is suspense in knowing that the answers may never be fully accessible, and yet there is comfort in imagining that life persists quietly, resiliently, and beautifully. The mystery becomes a companion, a reminder that we are not the sole arbiters of existence, but participants in a cosmos that teems with hidden complexity. The philosophical implications are equally profound. Hidden life challenges our notions of uniqueness, dominion, and awareness. It asks us to reconsider what it means to be alive, to be intelligent, and to be a conscious observer. If life exists in unseen forms, it suggests a universe that is interconnected, multi-layered, and dynamic, one where survival, adaptation, and perception take on forms beyond our current comprehension. We are reminded that intelligence is not limited to what we recognize, and that companionship across the cosmos may take subtler, quieter forms than radio signals or visible footprints. Embracing these ideas also invites a sense of emotional intimacy with the universe. Life, in all its possible forms, is not just a scientific concept, but an experience of awe and presence. When we imagine hidden life, We connect emotionally to the possibility that the cosmos is alive in ways that touch us indirectly. Through the resilience of ecosystems, the patterns of stars, the flow of energy, and the dance of particles that form the very matter of our bodies. The universe becomes less a distant stage and more a living, breathing presence, encompassing us, sustaining us, and reminding us of our small but meaningful role within its vast web. This perspective transforms observation into mindfulness. Looking at a pond, a forest, or a patch of soil is no longer a simple act of seeing. Each moment becomes an opportunity to recognize hidden interactions, to sense life that is invisible, and to acknowledge the persistent creativity of existence. The unknown becomes a source of gentle suspense, not anxiety, a quiet thrill rather than fear. It encourages us to slow down, observe more carefully, and appreciate the layers of life that operate beyond immediate perception. Hidden life also expands hope. It suggests that the universe is generous, abundant, and endlessly inventive. The possibilities are limitless. Life may exist where we least expect it, adapt in ways we cannot predict, and persist against odds that would seem insurmountable. In imagining these scenarios, we cultivate a sense of optimism, not certainty, but possibility. The cosmos may be richer, stranger, and more alive than we can currently conceive, and our awareness of it is still growing. Ultimately, revisiting hidden life brings the emotional journey full circle. It merges the rigor of science with the reflective curiosity of philosophy, balancing suspense with calm and mystery with wonder. It invites us to hold multiple possibilities at once. The universe is silent and speaking, empty and teeming, simple and infinitely complex. We may not yet perceive all that surrounds us, yet the act of contemplating these hidden forms of life connects us to the cosmos emotionally and intellectually. The quiet beauty of this idea lies in its open-endedness. Life may be around us, just beyond perception, waiting for discovery, or perhaps content to remain unseen. The suspense is gentle, the wonder persistent, and the curiosity it evokes both humbling and inspiring. Hidden life reminds us that the universe is more mysterious than we imagine, that existence is layered and multifaceted, and that the quest to understand it is a journey of both science and spirit. In the end, contemplating hidden life allows us to experience a deep, calm suspense, the kind that opens the mind and softens the heart. It is a recognition that we may be part of a cosmos already alive in ways invisible, intricate, and astonishingly beautiful. The mystery persists, as does our desire to explore it, a quiet, enduring curiosity that may define humanity itself and our place in a universe filled with secrets waiting for us to notice. Perhaps the most profound possibility of all is that communication with life beyond our perception does not require technology, signals, or instruments at all. Perhaps, in ways subtle and unseen, consciousness itself serves as a bridge between worlds. Awareness may ripple outward, connecting minds, patterns, and forms of life that are invisible, intangible, yet very real. To consider this is to imagine a universe where thought, attention, and presence are not confined to individual beings, but participate in a larger, shared field of awareness. That on Earth, life constantly exchanges information in forms that do not always reach human senses. Plants release chemical signals to warn neighbors of pests. Microbes adjust their behavior in response to the slightest environmental cues. Even animals communicate in ways we cannot perceive fully: ultrasonic calls, pheromones, electric fields. These hidden layers of connection remind us that perception is limited and that life operates in channels far beyond our own. If these forms exist on our planet, it is not unreasonable to imagine that similar subtle networks exist elsewhere, on scales both small and vast, reaching across worlds in ways that blur the line between self and other. Consciousness, then, becomes a medium. Thoughts, emotions, and awareness may extend outward, interacting with other forms of intelligence, whether biological, energetic, or otherwise. Perhaps when we meditate, reflect, or simply become deeply attuned to our surroundings, we are tuning into a subtle current that already flows through the universe. Our minds, our attention, may be both receivers and transmitters, participating in an exchange that is too quiet, too intricate, or too diffuse for conventional instruments to detect. This concept evokes a peaceful, almost sacred perspective. Life is not merely a collection of isolated organisms, but a tapestry of awareness, woven together in subtle and invisible ways. The universe itself could be alive with consciousness, layers of perception overlapping, intersecting, and resonating. Even without recognizing it consciously, we may already share in these connections, coexisting with forms of life that do not require our traditional understanding of communication. The idea also encourages patience and introspection. Just as we cannot perceive every vibration of a musical instrument or every flicker of distant starlight with the naked eye, we may not always perceive the ebb and flow of awareness around us. Yet knowing it exists encourages quiet observation and reverence. Each thought, each moment of mindfulness, becomes a gesture, a potential interaction with a broader, unseen network of consciousness. In this sense, the act of being aware is itself a form of connection, a way of participating in a cosmic conversation that transcends time, space, and matter. Philosophically, this perspective invites humility. Our minds are finite, our senses limited, and our understanding incomplete. The possibility that awareness flows beyond us, touching life we cannot see, reminds us that intelligence and life may take forms far more diverse than we imagine. To recognize this is not to diminish human experience, but to expand it, to see ourselves as participants in a larger, more intricate system of awareness, one that may include both visible and hidden forms of life. The emotional resonance of this idea is quiet yet profound. It transforms the sense of isolation into one of connection. The universe is no longer merely an object of observation, but a living, responsive presence. In imagining shared consciousness, we are invited to experience empathy on a cosmic scale, a recognition that awareness itself may be a unifying thread linking all forms of life, seen and unseen. Ultimately, viewing consciousness as communication transforms the search for life. It becomes not only an external quest across space, but an internal exploration of perception, attention, and connection. Perhaps the signals we have been seeking in the void are already part of the subtle exchange we participate in every day. Perhaps our awareness is intertwined with the rhythms of hidden life, resonating gently with forms of existence that have always been beside us, around us, and within the patterns of the universe itself. That in contemplating this, we cultivate a calm, thoughtful awareness. Life may surround us in ways we cannot measure, yet consciousness allows us to touch it, acknowledge it, and participate in it. The universe, in this view, is alive not only in matter and energy, but in awareness, a quiet, ongoing conversation that invites us to listen, reflect, and feel the profound connection between all that is seen and unseen. Imagine closing your eyes and sensing the world not just through your eyes or ears, but through an awareness that stretches beyond the familiar. In this quiet, expansive perception, life is no longer confined to what we can touch, see, or measure. It enfolds us, subtle and pervasive, a gentle presence that exists beside us and within us, yet remains hidden. The universe, in this vision, is alive in ways that are calm, persistent, and intimately intertwined with our own existence. The hidden layers of life might exist in air, in water, in soils that teem with microbial complexity. They might inhabit frequencies of light or energy that escape our senses, move in currents of plasma or patterns of information, or reside in forms so abstract that they appear almost ghostly to us. Yet, even if unseen, these forms are real, quietly shaping environments, interacting with one another, and participating in the ongoing dance of existence. The recognition of this possibility brings a gentle awe, a reminder that life is not rare or fragile, but resilient and abundant in forms beyond our imagination. This perspective invites serenity. To know, even tentatively, that life may surround us without our awareness encourages acceptance of mystery. We do not need to control, define, or fully understand it to appreciate its presence. Just as a forest hums with life unseen, roots communicating, insects coordinating, air and soil vibrating with unseen networks. So too might the cosmos contain layers of life operating silently, invisibly, yet profoundly. There is comfort in this. Life is not only elsewhere, it is here, quietly persistent, embracing us even as we move through it unaware. The poetic beauty of unseen life is that it expands our sense of intimacy with the universe. Every breath, every movement, every thought occurs amid this hidden vitality. We are never truly alone. The stars above, the soil beneath our feet, the currents of the atmosphere, even the quiet flow of electricity and energy may be part of a larger, interconnected web of living systems. To sense this is to feel a subtle companionship with existence itself, an awareness that life is a continuous, enfolding presence. Acceptance of unseen life also encourages humility. Our perception is limited, our instruments imperfect, and our understanding always incomplete. The universe may be alive in ways we cannot yet measure, yet this does not diminish our experience. It enriches it. By imagining life as abundant, pervasive, and subtle, we recognize that the cosmos is not only vast in space, but layered in living complexity, and that we are participants in a system far greater than ourselves. There is a quiet poetry in the notion that life quietly enfolds us. It suggests that existence is not a series of isolated phenomena, but an ongoing resonance, a rhythm of interconnectedness that transcends visibility. Perhaps unseen intelligence pulses through energy, flows in patterns beyond our comprehension, or whispers in forms that elude our senses. Perhaps the very fabric of reality vibrates with living activity, from the tiniest microbe to the grandest stellar current. Each interaction, each subtle shift, becomes part of a tapestry we are immersed in, whether we recognize it or not. The emotional resonance of this possibility is profound yet gentle. It brings peace in the face of the unknown, curiosity without anxiety, and wonder without urgency. To imagine life enfolding us quietly is to cultivate a sense of belonging within the cosmos. It invites reflection on our place not as isolated observers, but as participants in a living universe, touched by presence we cannot always see, yet can feel an intuition, thought, or quiet attention. In this view, life is both intimate and infinite. It surrounds us in layers, stretches across dimensions, and endures through time and space. Every breath we take, every heartbeat, every glance at the stars becomes part of a silent communion with existence itself. The possibility of unseen life transforms the world from an empty void into a space of subtle vitality, where the quiet, persistent rhythm of life resonates with our own awareness. As we close this reflection, we are left with a gentle serenity. The cosmos may be filled with life beyond perception, enfolding us in a quiet, enduring embrace. We are part of a living, breathing network of existence, and even in the absence of visible proof, the awareness that life persists around us invites calm, wonder, and acceptance. To live is to exist within this subtle web, to move with its rhythms, and to feel the quiet companionship of unseen life. As we step back from the vast mysteries of the cosmos, the question of alien life becomes more than a pursuit of knowledge. It transforms into a mirror reflecting our own existence. In seeking life beyond Earth, we confront the limits of our understanding, the depth of our curiosity, and the enduring capacity for wonder that defines humanity. Each possibility of extraterrestrial life, from microbial shadows to non-biological intelligences, teaches us lessons about humility, resilience, and connection, inviting us to see ourselves with greater clarity. The search for life beyond our planet highlights the fragility and uniqueness of what we know. Earth is a haven in the vast cosmic sea, a world teeming with complexity and diversity that is often taken for granted. The realization that life could exist elsewhere, in forms strange, invisible, or incomprehensible, expands our perspective, encouraging gratitude for the delicate balance that sustains our own existence. Our ecosystems, our atmosphere, our biosphere, all are precious and extraordinary, and recognizing their value fosters a quiet reverence for the planet that nurtures us. Yet the lessons extend beyond appreciation for our world. Considering alien life prompts reflection on adaptability and resilience. Extremophiles on Earth demonstrate that life thrives in conditions once thought impossible, suggesting that survival and creativity are intrinsic properties of living systems. From this, we learn that we, too, possess remarkable capacities to endure, adapt, and flourish, even amid challenges. Observing life's versatility across potential cosmic contexts inspires hope, reminding us that existence is not fragile in the face of adversity, but persistent, evolving, and inventive. The search also reveals the diversity of intelligence and consciousness. Imagining minds made of plasma, energy, or code challenges our anthropocentric view, encouraging humility. We are not the pinnacle of cognition, but part of a spectrum, one expression among countless possibilities. This awareness softens our ego and fosters empathy, as we recognize that awareness may take many forms, each valid, each capable of perception, communication, and interaction. In doing so, we come to understand that the essence of life is not only in its outward form, but in its capacity to experience, to observe, and to connect. Moreover, contemplating alien life illuminates the interconnectedness of all things. The universe, as we have explored, may be rich with hidden forms of life, subtle networks of awareness, and intelligence we cannot yet perceive. To imagine our presence within this vast, living tapestry is to cultivate a sense of unity. We are not isolated observers of an empty void, but participants in a cosmic community, part of a continuum that spans matter, energy, and consciousness. This recognition invites a shift from separation to connection, from fear of the unknown to curiosity and acceptance. The philosophical insights are equally profound. The existence of life elsewhere, or even the mere possibility of it, reframes our priorities and our perspective on time, achievement, and legacy. We see ourselves as fleeting sparks within a vast cosmos, yet sparks capable of reflection, creativity, and stewardship. In recognizing the potential for other life forms, we are reminded that knowledge and understanding are ongoing processes, that humility is as vital as discovery, and that every moment we engage with the universe is part of a shared, unfolding story. There is also a quiet spiritual dimension in these reflections. Life beyond Earth encourages gratitude not just for the planet, but for the gift of consciousness itself. To be aware, to perceive, to ponder our place in the universe is an extraordinary phenomenon. The contemplation of alien life magnifies this wonder, revealing the extraordinary nature of our own awareness. Each thought, each act of observation, each moment of curiosity becomes a celebration of existence, a recognition that life, in all its forms, is a shared and precious phenomenon. This understanding nurtures hope and possibility. Humanity's quest for cosmic companionship is not solely about discovering distant planets or signals. It is about cultivating openness, creativity, and imagination. The universe is vast, intricate, and alive in ways both visible and hidden, and in striving to comprehend it, we refine our own capacities for insight, compassion, and wonder. Each discovery, each unanswered question, is a step toward deeper connection with the cosmos, and through it, with ourselves. Reflecting on alien life, we also recognize the value of perspective. The Earth, with its delicate ecosystems and fragile balance, gains new significance. Our conflicts, fears, and anxieties shrink in the face of cosmic time and the vast diversity of existence. Observing potential life elsewhere encourages a calm humility, an understanding that while we are small, our awareness allows us to grasp the beauty, complexity, and continuity of life in ways that are meaningful and transformative. Perhaps most importantly, considering the unknown teaches us patience. Life, whether hidden beneath a distant rock, drifting invisibly through space, or expressed in forms of awareness beyond our perception, reminds us that discovery is not instantaneous. The universe operates on scales that challenge comprehension, yet it rewards persistence and attentiveness. This patience becomes a lesson in living, in attending to the present, nurturing curiosity, and accepting the mystery that surrounds us. Ultimately, the search for alien life brings us full circle to ourselves. It encourages reflection on what it means to be alive, to be aware, and to participate in the intricate networks of existence. It fosters humility in the face of the unknown, gratitude for what we have, and wonder at what might exist beyond our perception. Through this lens, humanity's exploration of the cosmos becomes not only a scientific endeavor, but a deeply personal and philosophical journey. The warmth of this perspective is subtle but persistent. Life beyond Earth, or the potential of it, acts as a reminder that existence is vast, mysterious, and profoundly interconnected. We are threads in a tapestry that stretches across space, time, and forms of awareness both familiar and alien. By recognizing this, we cultivate empathy, curiosity, and a gentle reverence for all that exists. The cosmos becomes a teacher, guiding us toward patience, understanding, and the quiet joy of being alive within it. In the end, the search for alien life reflects back upon us. It teaches gratitude for Earth and ourselves, humility in the face of vast mysteries, and hope for connection across unknown spaces. It encourages us to embrace curiosity without fear, to value awareness in all its forms, and to live with a sense of wonder and unity. In contemplating the unknown, we find lessons not only about what might exist out there, but about who we are, how we live, and the shared resonance of life across the cosmos. The journey of seeking life beyond Earth is as much about the process as it is about the destination. It is not only the discovery of planets, microbes, or signals that matters, but the quiet act of wondering, questioning, and paying attention. Curiosity, in its purest form, is a gentle force that guides us to observe, imagine, and reflect. It transforms the vast, silent cosmos from a distant abstraction into a companionable presence, inviting us to slow down and notice the richness that surrounds us. Patience is the companion of curiosity. The universe does not yield its secrets instantly. Signals are faint, planets are distant, and life, if it exists beyond Earth, may operate on timescales and in ways that defy our understanding. In learning to wait, to observe without rushing, we cultivate a mindful awareness that extends beyond the search itself. Each unanswered question, each faint signal, each subtle anomaly becomes an opportunity to practice stillness, reflection, and reverence for the unknown. There is a subtle comfort in this rhythm. Curiosity encourages us to look, to wonder, and to dream, while patience teaches acceptance and presence. Together, they form a quiet meditation, a practice that connects us with the cosmos even when it offers no clear answers. The act of searching, of scanning the skies, studying extremophiles, contemplating consciousness, becomes meaningful in its own right. The process is its own reward, a gentle invitation to live with openness and attention. Mindful curiosity also nurtures gratitude. Every new insight, every question raised, reminds us of the beauty of our own existence and of the extraordinary complexity of the universe. Observing the interplay of life on Earth, the delicate balance of ecosystems, and the possibility of life beyond our perception deepens our appreciation for what we have and what we seek. The vastness of the cosmos is not intimidating when approached with patience. It becomes a source of inspiration, wonder, and quiet joy. Moreover, curiosity and patience teach humility. They remind us that we are small participants in a vast and intricate universe, that understanding unfolds gradually, and that some mysteries may remain forever beyond reach. This acknowledgement does not diminish our role or our experience. It enhances it, encouraging us to embrace uncertainty as a natural and even beautiful part of existence. To wonder without rushing, to question without needing immediate answers, is to live fully in the present while remaining open to the future. In this mindset, the search for alien life transforms into a reflection of life itself. Just as organisms adapt, evolve, and persist, our curiosity adapts and expands, guided by patience and observation. The act of seeking becomes a mirror for personal growth, a practice of openness, attentiveness, and gentle perseverance. Each step, whether yielding answers or deepening questions, is an expression of engagement with the universe, a conscious participation in the unfolding story of existence. Even in moments of silence, When the stars offer no clear signals and the universe seems still, there is meaning. The patience cultivated in these moments allows wonder to flourish, imagination to expand, and empathy to deepen. Curiosity becomes a bridge between the known and the unknown, the visible and the hidden, the fleeting and the enduring. It invites us to embrace mystery not as a void, but as a presence, an expansive, gentle companion that encourages reflection and joy. Ultimately, curiosity and patience remind us that the search is ongoing, infinite, and profoundly human. It is a practice that engages both mind and heart, blending observation with reflection, questioning with acceptance. Each glance at the night sky, each contemplation of hidden life, and each quiet moment of awareness becomes part of a larger rhythm, a meditation on existence, resilience, and wonder. By valuing curiosity and cultivating patience, we learn to appreciate not just the answers we may someday find, but the richness of the journey itself. The cosmos, in all its mystery, becomes not an object to conquer but a teacher to guide, a companion to accompany, and a space to inhabit with mindful attention. In this way, the search for life beyond Earth mirrors the search within, inviting us to explore with gentle persistence, to wonder without haste, and to embrace the beauty of existence in all its forms, known and unknown. As night falls and the world grows quiet, we find ourselves under a canopy of stars that stretches endlessly overhead. Each point of light is a distant sun, a reminder of the vastness beyond our planet and of the mysteries that still lie waiting. In this gentle darkness, the mind slows, and a sense of calm settles over the heart. The universe, immense and unknowable, invites us to pause, to breathe, and to simply be present with the wonder it offers. Beneath the twinkling lights, it is easy to imagine life unfolding far beyond our perception, on distant planets, in hidden realms, or in forms so subtle they escape our senses. Yet even if we never see it, the thought of unseen life enfolding the cosmos provides a quiet reassurance. The universe is alive, persistent, and profoundly intricate, and we are part of it. Each star, each shadow, each whisper of the night reminds us that we exist within something greater than ourselves, a vast tapestry of being and awareness. This is a time for gentle reflection. We can consider the incredible resilience of life on Earth, from the tiniest microbe surviving in boiling acid to the astonishing diversity of creatures thriving in every corner of the planet. We can imagine intelligence in forms beyond biology, consciousness woven through unseen dimensions, and life quietly persisting where we cannot detect it. These reflections are not urgent or demanding. They are invitations to marvel, to feel humility, and to rest in the knowledge that existence is vast, complex, and endlessly surprising. The night sky, in its quiet majesty, encourages mindfulness. To lie beneath it is to witness the universe without expectation or pressure. Thoughts of alien worlds, hidden life, and cosmic awareness drift through the mind like a slow, soothing river. In this moment, curiosity does not push us to seek answers but allows us to linger in wonder, to embrace the beauty of mystery, and to appreciate the subtle rhythms of life that connect all things, seen and unseen. As we settle into this calm, there is a sense of unity with the planet, with the stars, and with the possibility of life in forms we cannot yet perceive. We are participants in a story that spans time and space, threads in a fabric far larger than ourselves. Each breath becomes a meditation, each heartbeat a reminder of the delicate balance that sustains life and consciousness. Even as sleep approaches, the mind can remain awake to this quiet wonder, carrying it gently into dreams. There is serenity in imagining that life surrounds us, enfolding us quietly, whether in soil, water, air, or the hidden networks of awareness we have yet to understand. The universe does not demand our comprehension, only our presence. To rest under the night sky is to be reminded that the act of existing is itself extraordinary, that mystery and beauty are constant companions, and that the search for understanding is as much about embracing these truths as it is about finding answers. In this space of calm reflection, gratitude naturally arises. Gratitude for the planet that hosts us, for the senses that allow us to perceive, and for the mind capable of imagining worlds beyond our own. Gratitude for the quiet moments that allow contemplation and for the stars that offer perspective and inspiration. In this awareness, the night sky becomes a sanctuary, a place where the soul can breathe, the imagination can wander, and the heart can rest in gentle awe. The cosmos, in its vastness and mystery, offers lessons not only about life beyond Earth, but about our own capacity for wonder. Each twinkle, each distant galaxy, each hidden possibility reminds us that we are part of a living universe, connected in subtle and profound ways. This connection does not demand understanding, only recognition, a soft acknowledgement that we exist within something magnificent, intricate, and endlessly unfolding. As sleep draws near, these reflections can become a lullaby of sorts, a gentle meditation on existence. The mind can float with the stars, drifting along currents of thought and curiosity, while the body rests in quiet awareness. In this space, questions of hidden life, cosmic intelligence, and consciousness beyond our perception transform into feelings of calm fascination, leaving us open to dreams filled with possibility and wonder. And so, under the night sky, the search, the wonder, and the reflection come to a peaceful pause. We are surrounded by mystery, embraced by the rhythms of life, and connected to a universe that continues, quietly and magnificently, beyond what we can see or measure. In this gentle closing, there is comfort, serenity, and the enduring invitation to dream, to wonder, and to rest, cradled in the infinite presence of existence.